bum 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 bum. Bam 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 bam. Hello, hello, hello. 1, 2, 3. Oh, nice, and the bot is still working. Just okay. Nice. All right. Hello, hello, and welcome back. We're going to work on cast today again. What are we going to do? Well, last time we were trying to make the higher kind of types work, and I was doing a little bit of work off stream to fix some of the things. So some of the things were fixed, but some of the things are still buggy. And I guess I'm just going to be fixing the bugs. So my monad example no longer works. We have some issue here that t is not equal to _0. And I was trying to have the minimized example. And I found the minimized example. So here is the here's the test that we're doing. This is the minimal test that I have found. So the problem here that we have is that we have a function. We have a generic function. Not even a generic. So like yeah, we have a generic that returns a generic, or which returns this thing, right? So in this case, M is basically the higher kind of type, right? So that we can instantiate this with like some concrete type, right? Yeah, and this does not work. So why does this not work? Why does this not work? So the problem is that I am trying to figure out the type of this, right? What is the type of this? So when we are figuring out the type of dependent functions, right? Because this is dependent. The type that we are returning here depends on this value, right? Hello, Infinite Coder. How are you doing? Welcome. You beat Nigel. Yeah, it's because I streamed earlier today than I guess in the last multiple in the last weeks. I have been streaming late, but this time I'm doing it early. All right. Yeah, I'm trying to like fix the language. We have the higher kind of types almost working. I just need to fix a couple bugs, you know, and like I almost have like dependent types, and that's like, and the higher kind of types is basically the simple like example of a dependent type, basically. Top of the morning. Yes. Hello, Death Razor. Scary functional concepts. Well, there is nothing scary here. You're making a plaster mold. This time for aluminum. Soldering. Yeah, I don't know. That's nice, I guess. I don't think I would be into soldering though. I like software stuff. I don't like dealing with hardware. You seem to converge to your good old imperative language. Well, your good old imperative language still have these concepts. It just doesn't call them that. This is just a generic, right? We don't say dependent type. Don't forget about it. This is just a generic which returns a generic. Okay? This has nothing to do with functional programming, right? It is just a generic which returns a generic, right? For example, let's say that I was writing Rust and I would say something like this, you know, struct. Let's say this. Let's say this. Struct. No, maybe not struct. How would I go about this? Maybe trait. Maybe trait would be nice. Maybe trait would be nice. Trait foo, which has generic, like x or m in this case, right? Trait this. Yeah. And then you have function foo, which is generic over t. So inside of your generic trait, you have a generic function, a generic method, which should return m t. Now you cannot do this in Rust specifically, right? Because this is in Rust not supported. You cannot have as argument to your generic the generic thing. This must be the concrete type. What you can do though is kind of similar to this. You can say that this is like trait, you know, let's call this HKT, just for no reason. Don't think about it much. It's just a trait HKT, which has a type output, which is a generic associated type t, like this. That's something that you can do in Rust, right? So over here, I will say am : output t, right? There you go. That's what we're trying to get into here. Forget, it's not hard kind of type, you know. Let's say lower kind type. Sure, just so that you're not scared of this, right? That's what we're trying to get into here. Yeah. So basically, over here we say foo is m. Sure. Where we have foo, which is this. Right? Like over here we're going through the interaction of m to : output. I don't really need this here. Although I could say m.output t, I guess, to make it completely similar. Let's try make it really the same. How would I write the alternative of this? So m is going to be like a lower kind of type, and I will say like that lower kind of type is this, where output is t type. There you go. That's what we want here. What is cast? Cast is my programming language. Hello, precious Chin. Cast is my programming language. Well, you asked what is cast. Is there a cast on the screen somewhere over here? Well, I mean, yeah, that's my project that I'm opening, and it's over here. It says that it's my programming language, right? But yeah, let cast be Rust++. Yeah, we can call it Rust++. I mean, yeah, no, it's far from being Rust++ for now. Maybe at some point. Alright, let's say that this over here is going to be like Rust. Rust is this. And this over here is cast. Does this work? Let's see. Well, this does not work. Wait, no, it says statement must be expression. Because this is not a colon. Yeah, I don't need this to be a colon. Okay, there we go. And the problem is that M does not have fields. Wait, but it has fields. What do you mean? This is a type. M does not have fields, but the type of it is HKT, which has a field called output, right? Obviously. This is the interpreter error, by the way. While evaluating this, oh, yeah, I cannot do this right now. Yeah, that makes sense. That makes sense, actually. I cannot do this right now. I should be able to do this. Because this over here is the argument, right? We don't know the value of this yet. So at compile time, I cannot get this field, right? I can fix this actually right now. Let's do this. So this is another example of the dependent type, because we are trying to get a field of the value which is not available to us yet, because we're trying to do like evaluate this at compile time. At compile time, M is the variable which is of type HKT, and we don't know the type. We know the type of it, but we don't know the value of it yet because it's just an argument to the function, right? Yeah, let's actually do this too then, because foo is generic and it should be evaluated when generics are passed. No, I mean, we are trying to like evaluate this type, right? What is this type? We're trying to like during compilation, like figure out what did I write here, right? So what does m.output mean? So usually when you see the dot, you're trying to get the field of the of an object, but this is an object which is which doesn't have a value because we're compiling, not running this yet. So I don't know the concrete value of this argument. You need to evaluate the type when you have a generic argument. You need to evaluate the type when you have the generic argument. What? Which type? This type, evaluate. When I see the type, I always need to evaluate it. It doesn't matter if I have the generic arguments or not. When I see the type written here after the double colon, I need to evaluate it to figure out what is written here. You can evaluate the function before passing the params to it. Well, yes, but no, that's where you're wrong, because we are able to evaluate the things before passing the params to it, right? Because we must do this evaluation at compile time to figure out what is written here. Like, I guess usually you don't call this evaluation in your normal programming language because I'm a functional programmer. No, it's not because I'm a functional programmer. It's because I am an imperative programmer, and I am just saying that this is an expression which returns a type which must be evaluated at compile time. It has nothing to do with function programming. It is normal imperative programming. It's just evaluation happens at compile time, similarly to languages like Zig. Zig is not a functional programming language, and it also has evaluation at compile time. I'm UTC plus 8. Where are you? I'm UTC plus 4. Okay. So yeah, we must evaluate this at compile time, and at compile time we are not having this, so we cannot evaluate the function body before passing the argument, right? Which we are fixing by saying that during compile time this is a variable which does not have a value. It's a special kind of a value which is blocked on runtime, and it can only be fully evaluated when we actually like call this function with this argument. But so we must be able to do evaluation with some values which are only going to be available at runtime. I need to like figure out how to explain this to the like to the users who are. It's kind of like to me this is obvious. This makes sense, and it has nothing to do with function programming, I think. But yeah, we basically. You had a thought about doing generics in a compiled language at runtime. Yeah. I don't know what you mean by that, but so basically we blur the line between the compile time and runtime, and which means that I can have generics at runtime because I can have generics at compile time because compile time is runtime because compiler is interpreter. Anyway, let's fix this first. So basically, I need to evaluate this, and it's going to be another value which is blocked, and it must be like it's blocked, and it can only be evaluated at runtime. Is the thing. So I have special thing which is called blocked value. Blocked value is the thing which is a variable without a name. So it's either a binding, and I also had this thing which is instantiation, which is necessary for higher kinds types, because it's basically like calling a function, but we don't know what the function is yet, because we're not at runtime but at compile time, right? And another thing that we have is blocked value, where we are getting the field. Right, get field, similar to expression field. Yes, place expression field. Should it be placed expression then? Interesting. Should it be place expression then? Hello, Elemental Magic card game. Hi. Types are not kind to me today. Do you just bundle your compiler with every executable? No. I don't have executables yet. I only have the interpreter, which is the compiler. And compiler is interpreter. So you remade Python. Yeah, you can think about it as Python, yes. Python is working similarly, actually, yes, with its type annotations, I guess. Just Python is not type checking your program, really, right? And there is no inference happening, I guess. All right, field. Interesting. So like at runtime we have the differentiation between the place expressions and value expressions. So I split the field normally into two expressions. We figure out what is the place of a field, and then we claim the place to retrieve the actual value if we need to. So I'm wondering, does it mean that it in blocked values? Python syntax is also absurd, like recursion in Python is spelled while simply recursive function calls are not actually recursive. How are they not recursive? All right, I'm just thinking, if I have a field, you actually have to use one of the loop keywords to do recursion. You trolling? And manage your own stack frame manually. If you are going to overcome the stack overflow, that's something that you would do in in C2 and in like most of the languages, I guess. If you want to make sure that you are not overflowing the stack, then you need to manage the stack yourself, just like you said, in any language, including C. Languages like OCaml do that for you, basically, in the runtime, I guess. Not in Haskell or OCaml. Well, I mean, in Haskell, it's the job of the Haskell's runtime, basically, similarly to OCaml, right? Because your stack is actually living on the heap in OCaml and in Haskell, I guess, too. You're barely using the stack because the programming language is not giving you access to the low-level details of how your stack is implemented, and so they implement it for you on the heap, right? It's just that in C you have to do it manually. Python could easily do it as well. The issue is tail recursive functions generate extra stack frame for no reason in Python. This can be understood at compile time, but the optimization isn't done. I'm pretty sure that maybe your information is wrong. Python, tail, recursion. And you are talking only about tail recursion, right? Because they're like recursion is not limited to tail recursion. Python tail recursion. They are going to implement tail recursion finally. CPython tail call interpreter is merged for Python 3.14. Your information is old. This happened in 2025. Python is the Haskell you never knew you had. What's new in Python 3.14? A new type of interpreter has been added to CPython. It uses the tail calls between small C functions that implement individual Python opcodes rather than one large CK statement. For certain neural compilers, this interpreter gives significantly better performance. There's also free threaded mode, whatever that means. Yeah, they disabled the global interpreter lock too, right? Before that. and stuff. Anyway. So now their syntax is only slightly weird. What's weird with the syntax, and what does the syntax have to do with the implementation of the runtime? Because syntax did not change, right? It's that the interpreter written in C is now structured using tail calls, not that tail calls are there in Python. Is that not? I don't know, anyway. Compare list comprehension in Python versus Haskell. Well, it looks a little bit differently. What's weird about it? Python, a list comprehension. Haskell, a list comprehension. Sure, let's compare. Let's not work on my language. Let's instead look at Python and Haskell. X for X in fruit if A is in X. C for C in S to upper C. Slightly different syntax, meaning the same thing. What's the difference? The difference is in the syntax. I see that this and this is the same thing, just slightly different syntax. Which actually is Python is actually more readable because it uses actual words instead of symbols. I'm surprised Haskell uses mod instead of like the symbol here. But the Haskell symbols are what you see in a math class. It's a programming language, it's not a math language. Well, I mean, I'm assuming you are trying to program and not to math when you're making your Elemental Magic card game. Math is weird. I don't like a lot of like things in math. They are there for historical reasons more than like a lot of math is actually not readable, but they still use that syntax for historical reasons or something. The Haskell version is declarative. Python's version is also declarative. Like it's literally just symbols replaced with the words in Python. Specifically in the list comprehensions when you are complaining about. Hello, Roberto Martinez. Are you making a game entirely in Rust? Yes, my game is written in Rust. I am using a custom game engine for it. Also for using to make games, music and sound effects. Graphics is made in Sprite. I'm not the guy. I'm doing the code though. We have 3 people and music is handled by a different person and graphics and level design is also handled by another person. Yeah, but right now we are working. Hello, Ainfachivo. I'm working on my programming language, yes. This over here on the screen is OCaml, which is what my programming language is written in. And what's the name of the game engine? It's called Geng, for game engine, G-E-N-G. yeah, so okay, let me try focus on my programming language. I have a problem right now where so we have like the Rust version here of some higher kinded stuff, and I cannot do this over here right now. m.output, m is the argument to this generic thing, which has the type, which has the field output, but we don't know the value of m at compile time because that's just an argument, so I cannot know what this is right now, which means that this must be delayed. And the stuff. Hello, John Anderson. He's too cool for Bevy. No, Bevy is too cool for me. Alright, so I'm trying to introduce the new kind of a blocked expression, of a blocked value, because we are figuring out the types by evaluating this thing at compile time. But I cannot evaluate this because we don't know the value of m, which means that it's a blocked value. Blocked value. So I want to introduce a new kind of a blocked value, which is me getting a field, but the problem is... if I have a blocked value field... Should I have like a blocked value, like a read place, basically? I guess. Of like it should be... maybe it should be like read reference. Claim. Claim reference. And then getting the field. So like we will split. So instead of getting the value of the field directly, what we're doing right now in the interpreter, because we like we should be able to get the reference to the fields, we split our expressions into place expressions and value expressions, and similarly to that, my blocked values also should be like split like this. How did you start making your programming language? By... yeah, originally I was just trying to try OCaml because I like trying new programming languages. And usually when I try a new programming language, I was writing like a simple, like not a game, but when I learn a new programming language, my usual hello world was trying to draw a triangle on the screen with OpenGL. But this time, when I was trying to learn OCaml, instead I tried to make a simple programming language, and then that's how I got into making a programming language. Instead of it being simple, it's now the most overscoped language ever, and I will never finish it. But you know, field ref blocked value field ref, and blocked value field ref is object is blocked value. The language is not ready yet, no. Primarily used. It's a general purpose programming language which is supposed to be used for everything. Just like most of the other programming languages. Can be used for anything. I'm going to try and use it for making games. And that will include writing, for example, shaders in it, not just the logic of the game. So it's a language that I want to be used on both CPU and GPU, for example. We can also use it as a scripted language for faster development cycle. It's supposed to have an interpreter and a compiler. Right now I only have the interpreter for now. Is field in this case a string? Maybe. So here's the thing: when we see object dot field, the way we compile this right now is we are saying that this is going to be expression claim, where we are trying to claim the place, which is place expression field of object and field, right? So that's why we're doing this. So basically a place expression is giving me the reference to the field, and claiming is dereferencing the field and getting the actual value out of it. Yeah. That probably makes sense. If I do it like this. Okay, let's then follow the error messages. Alright, so what I'm doing right now is I'm trying to say that we have how do I say what I'm doing? Adding field expressions to blocked value, whatever. That probably doesn't make sense. Anyway, but we're trying to print the block, like it's basically the normalized expression, I guess. Or whatever. Right, I'm going to just work on this instead of trying to explain it, I guess. If we have a claim reference, then I need to print. So this is basically dereferencing, right? So I'm just going to say this, print blocked value reference, and if we have a blocked value field reference, object and field. This is going to be printed as let's say in round brackets, I guess, reference to object dot field. Print blocked value object. It's the string. Okay. It's going to be like looking a little bit weird because I'm going to say like I'm going to take the reference and then do this, right? But we can also like we can like detect that I'm dereferencing the reference immediately. And in this case, show it normal, or maybe like even convert it to like just the blocked value field instead of going to reference and then claiming it. But let's think about that later. So here's my inference. When we have the blocked value field reference, object is object A, field is field A, and blocked value field reference object is object B, field is field B. This only can unify when field A is equal to field B, and in this case we will return field reference where object is unite blocked value object A and object B. Field is any of these. Okay. And if we have a field reference and anything else, then we fail this unification. Some record fields are undefined. Oh, because I used a comma here instead of semicolon. Pattern match is not exhaustive. Oh yeah. So this is the field ref, and then we have the claiming the reference A, and claim the reference B, claiming reference and whatever is going to fail. So in this case, we are going to claim the reference of united A and B. Hello, Nigel. Hi. Dumik Bog. Yeah, just arrived earlier today. Let me know if there is any sound issues. It should sound good. I tested before the stream, right? I think it sounds good, right? Substitute blocked. Blocked value. Okay, so now when we actually have, so we are trying to basically calculate the value which is blocked by at some point we can we are going to know the object of which I'm trying to get the field, which means that I can get the reference to it, right? So we have object, field. In this case, we're going to binding, name, state, scope. No. Okay, yes, we're going to say that object is substitute blocked Opaque? What do you mean opaque? Oh, what's a blocked value? So in the dependent type theory, they call it neutral values. Do you know what this is? Neutral values. Dependent type theory. Neutral types and neutral values. Cast has officially gone beyond what I understand. Okay, so as you can see here, we're doing normalization by evaluation, right? What's the problem that we're solving? Okay, let me talk about it a little bit. What's the problem that we're solving? We're trying to see that like we're basically trying to do type checking, right? Which means that we need to be able to check that two types are same types, right? And the type, for example, can be a function, because like the type is like, because we're using like in higher kind of like you understand higher kind of types though, right? So we need to, yeah, we have type constructors, right? So your type can contain type constructors, right? So how do we know that type constructors are the same? We need to check that the types, when constructed, are going to construct the same types, right? That's how we check it, right? So type constructor is basically just a function, right? So we have a function that returns the type. That's what the type constructor is. So how do we know that two functions return the same values all the time? We need to basically normalize the functions to some canonical form so that we can actually compare them, right? Because functions can be can be semantically the same, but syntactically they can be different, right? So we need to normalize them, and we are doing normalization by evaluation, which means that we are basically trying to evaluate the body of the function, and that is going to result in its normalized form. But how do we evaluate the body of the function without actually calling the function with a concrete value, right? It means that we must be able to evaluate the function with variables which are blocked, which are only going to be available at runtime, right? That's why I call it blocked values. Dependent type theory is calling this neutral values because you cannot progress your evaluation further, right? But it's basically a value that is blocked at compile time. It's going to be unblocked at runtime when you actually call the function with the concrete argument, right? So we're working with like abstract things which we don't know what they are, right? So how do we evaluate the expression calling a function f with argument x if we don't know what the function is f? If the f is blocked, then we basically say that the result of evaluating the function f called with argument x is literally calling function f with argument x. That's what we say. That's what the result is. The result of fx is fx, right? So we basically like remember what were we trying to do, and then at runtime, and then like at some point at runtime we can make more progress, right? So this leads to us having the like the resulting value is only going to contain the things that we cannot make the progress on, and because of that it's going to basically automatically be the normalized form of the function, because everything that could be done at compile time is already evaluated at compile time. It's basically like very similar to like const propagation, I guess. So we propagate everything that is possible, and everything that is not possible is going to be like left as is, right? And that results in us having the normalized form of a function, which we can compare against the other functions. Now, okay, so we do normalization by evaluation. And right now, what I'm doing is that I'm trying to evaluate the field of an object where I don't know the value of the object yet, right? So object itself is blocked, which means that we need to remember that we were trying to get the field. So we have a new type of a blocked value, which is trying to get a field of another blocked value. So it's kind of like yeah, in short, your compile time terminal for your AST is not the runtime terminal. Unstable Deus. Your compile time terminal is not the runtime terminal. What is terminal? Terminal is like the final value, I guess. Yeah. So when we evaluate, we don't evaluate fully because we don't have enough information at compile time to evaluate the value fully. So we only evaluate it partially, I guess. Yeah. All right, so we have the object, and over here I'm doing the substitution where we might already know what the value is. So we replace the object, and when we replace the object, it might now be known, and now I can progress the evaluation basically. So the original value is blocked object, state object. Okay, now this object, interpreter instantiate object. I remember you were thinking of comparing them by passing an abstract value already. Did you end up finding theory on that? Comparing them by passing the abstract value already? I mean, yeah. Terminal value in AST which cannot be substituted and evaluated further. Yeah. Yeah. So dependent type theory is calling them the neutral values. So they call it neutral values because it cannot be substituted, rewritten, evaluated further. Why is it neutral again? I don't remember why. I asked ChatGPT why they call them neutral. Why does dependent types call on some values neutral? Some values are stuck, so, right? So I call them blocked. They're stuck. We mix computation and typing. Neutral values blocked but legitimate, right? Yeah, okay. Canonical values fully cooked. So yeah, literals are the most common form of a terminal, but certainly not the only form of a terminal. Yeah. Are you familiar with this theory, Unstable Deus? I'm only familiar with it like because I'm trying to make something that resembles this. I have not actually like read much of the theory. I read a little bit, but not all of it. You remember stuff from your compiler course? Do they teach dependent types in the compiler course? Well, I guess if they teach you like type theory, then type theory includes dependent types, right? Although normally, like when you do the compiler course, I would expect them not to include dependent types in them. I don't know. I never had a compiler course. I'm self-teached, I guess, in that field. We had to make grammar and how that would be processed into the AST. Yeah. Yeah, so like normally in the compiler development, you have your compiler divided into stages. You have a separate compilation stage and separate evaluation stage. And what we are trying to do is we're trying to blur the lines between compilation and evaluation. I want to be able to do the evaluation at compile time anyway, similar to languages like Zig, for example, which allow you to just like sometimes you just want stuff to happen at compile time. I don't know, you want to like derive a trait for your type, right? In Rust you write a derive macro for that, which basically runs code at compile time, right? But in Rust it's like more divided, and it's like a separate binary that is running, and we're trying to actually blur the lines properly. And it also leads to some other things that we can do, which includes dependent types, I guess. So basically it means that the compiler is the interpreter. There is no so we don't have a separate type checking phase, we don't have a separate compilation phase. Even during like not during parsing, but I guess during the conversion of like concrete syntax tree into the abstract syntax tree, the evaluation also can happen because there are macros to expand, for example, right? Yeah, in C++ you can use template instantiation to do compile time evaluation, yes. But in C++, this is like a separate language, right? In C++, there is something closer to what I'm trying to do, which is like const expressions, right? Yeah. So we're trying to make it the same language so that it's easier, I don't know, to understand. And it also allows us to have a more stronger type system with dependent types, which will allow us to catch more bugs at compile time, I guess, which is a good thing. All right, anyway, so we have the object, and now I need to get the field of this object, right? So I just literally need to progress the evaluation here, right? Yes. Okay. Interpreter. So I need to be able to know how to get a field reference. So this is going to be, let's see, we have interpreter core. Unfortunately, I have like some, yeah, so like because of that, the language is highly recursive and I'm having trouble like structuring my code. Because inference can result in evaluation and like things like that. And evaluation can result in inference can result in evaluation. These are like things are recursive, so like, yeah, there is a problem because of that. So I need to do this field my bad, sorry. Okay, let me see when I'm evaluating the place expression field, right? I want this to be extracted into the I want this to be extracted into a function, so I can call this from over there. Object and field. Field expression. Oh wait, I have evaluate field expression already. Oh wait, no, this is field expression. Yeah. Okay. Member, yes. So object is a place expression and field is a field expression. Member is a tuple member. Like when I'm doing it here, what I was trying to write, right? I have the object, which is a value, which is not an expression, right? Yeah. So over here, place expression. I have evaluated this already, right? Yeah. Wait, field reference. Field reference means that this also must be a reference, by the way, right? This also must be a reference. So this is a reference to the object, and I'm trying to get a reference to the field then, right? Because, yeah, object is a place. Yes. Okay. Makes sense. Makes sense. And I evaluate this too. Okay. So then this is the function that I just need to... Yeah, like literally this one, get field. We're going to get field, object, member. Okay. So get field, object, member is this thing. Where's the syntax problem? Oh, this one? Okay. So we say that interpreter dot get field is get field. There we go. So the type of this is object value. Yeah. So we have a value member and we get a place. Yeah. Okay, so I actually do have a value here. Okay. Get field, this returns a place. Yes. Okay, good. I must have get field member. Replace. So I need to give it expected type then, right? Expected type. That's going to be this thing. And then I need to give it the span for reporting the errors. Error place, expected type, like that. Get field, span, expected type. There you go. Oh, cast module as option. Yeah, I need like to have the state here too. Yeah, because we're doing the evaluation state. Because wait, why is this state needed? Cast module as opt. Cast as module opt. Sure. Okay, let's do that. So now, place get field here must be called with state. Expected type, in this case, is expression data type. Wait, is it actually expression data type? Maybe. Maybe this needs to be substituted. And span is expression span. Or do I have span here? Yeah, I have span here already. Okay, so now this has a different thing, right? So, but this should be result type, which is type. Span state, interpreter state, result type. We have a value and we have the tuple member, and we get the place as the result, and all of this is the reference and optional. Okay, sure. Yes, so now what we do is we just say that get field is that thing. Okay, get field, result type is blocked type, span, state. Now we have the object, which is the value. We have the object, which is the value. I feel like this must have a place after all. This is a value, but this value must be a reference, right? Object, and the field is name field in this case, right? Field ref, or we can also say that field ref is you know, field is field can just be tuple member directly here. Unbound value equal member. Do I have equal here? We just do deriving equal and OR here. There we go. Yeah, so over here is going to be A, which is going to be tuple member print field. Okay. Tuple member equal. All right. Unbound value interpreter get field. I think OCaml language server is having a bad time again. Unbound value interpreter get field. Oh, okay. We call this get field. Okay. So I don't say name field, I just say field here. The expression has type place, but expression was expected of type value. Yeah, so get field results in the place, and place is basically the reference. So we are going to say that place is this, and then we return value reference, place value inferred span, right? Value reference as mutable, or yeah, okay. Value reference mutable false place. Okay, and then one more thing, which is blocked value claim reference. In this case, we say that reference is substitute blocked original value blocked reference. I feel like this should be extracted. And then we just say that we want to dereference the reference, right? Which means interpreter which means interpreter claim reference. Claim reference. So reference is just a value, and we expect this to be a reference and claim it. Okay. So claim reference is... we probably also need span, result type, state, interpreter state, value, and this gives me the value. Option ref is ref none. So I need to give it the result type, blocked type, span, state. Claim is move. Yes, claim is move or copy, depending on the type. Right now I just copy everything, right? But eventually, similarly to Rust, we have some types which are moved and sometimes which are copy types, for which move is not move but copy, right? Yeah. Claim is used in the blog post where Rust was thinking about this, implementing the claim in addition to the current copy, clone, and moves. As something in the middle. So yeah, this is not necessarily moving, because moving means that the original value no longer exists, right? Claiming means that I want to have the value, but whether the original value remains in its place is a question which depends on the type, right? The value get field has type state. Oh, has result type, expected type. I cannot go to the definitions to be a common language server. Ah, yeah, go to result type here instead of expected type. This over here was optional. This one is not optional, but yeah. Sure, let's go to result type instead. The value get field has type state span result, so like it's the other order. The order also matters here, I guess. We must have a span and then state and then result type. Okay, nice. And now I need to implement the claiming reference. Claim reference is claim reference. Okay, claim reference. Claim reference, claim reference. How do I make claim reference? Claim claim underscore. Claim reference. So claiming normally is something where I claim the place, right? But claim reference is... Okay, let's see. Span, state, result type, reference. This must return value. I need to basically say reference value await inferred. I need to match this with, if it's a value reference to a place, then we actually claim the place, right? We actually claim the place, span place. But if it is anything else, then we error. Expected a reference. And we return value error. Where's the syntax error? I forgot the semicolon here. Okay. Place. Okay, yeah, we have value reference, which is like mutable place, right? Whatever. Claim. What is this? What is this? Why did I do that? Well, so I claim not just the place, but whether the place is mutable or not, which also is ignored. Where is this used? Over here. Claim span. Because when I evaluate the place, I know whether the place is mutable or not. Okay, no, forget about it then. Yeah. I can do over here, claim underscore. I mean, it's going to be unused anyway, but we can do that, I suppose. Okay, so, and the other thing that we can evaluate into a blocked value. So if it is a value which is blocked, blocked. Then what I return is I return a new blocked value where shape is blocked value claim reference blocked. Right, and we also, for blocked values, we also must have the type. So type is result type in this case. Okay. Yeah. It seems like I don't need the state here. It's weird that this, yeah, this over here has says state, but this over here says state A. Because I'm not using this, it doesn't matter. Wait, does this mean that OCaml has subtyping? Actually, because I'm assigning this type to this type, which are different types, because this one is polymorphic and this one is not. OCaml subtyping. Oh yeah, OCaml has subtyping because there are polymorphic variants at least, right? Okay, so that is the thing. So get field, claim reference, okay. And get field, by the way, is another thing, right? So now when we get field, this over here can also be a blocked value, right? Get field returns the place. Yes. This is very interesting to watch. Loving it. Do you understand anything? Because I'm not sure if I'm very good at explaining myself. I'm trying, but feel free to ask questions. So when I get the field, the value is itself blocked, which means that we return a new blocked value. Type is result type. And shape is blocked value field reference. Wait, this returns a place, which means that this should not return a place though anymore, right? This no longer returns a place. I need this to give me the value reference. How much do you press? Press what? I only press buttons on my keyboard. I press a lot of them. The bench? I don't do bench. I mean, I did it a while ago. Press is... I think the maximum that I did was 80 kilograms. I don't remember though. It was a while ago. Like more than 10 years ago, I guess. Is 80 kilograms a lot? Need a pull request to add push-ups to Kuvibot? I mean, you can. If you want. Well, it was more than my own weight, I guess, right? Enough? You are enough? Blocked. So you have to do push-ups every time someone types push-ups 10? No, that's... no. Oh... Okay, yeah. Okay, so this means that the get field should return, like, because I cannot have a blocked place. I cannot have a blocked place. I can only have blocked values. But place is basically a reference. So get field. How about I mean, I can make this return a value, but then I'm using it in the other place, and then my value must be a reference, right? I mean, yeah, that actually is what I need to do. Anyway. So get field is going to be called get field reference then. So this is going to be value reference. But value reference, is this mutable or not mutable reference is the question now. Maybe it just depends on the field itself, field place. That's the place mutability. Let's just say true here. I don't know. We always have this thing. Sure. Place init. The error place. Okay, hold on. With return. Function return. I guess I want to have a place after all. In most of these cases. And if I have the place, then I will return this. Return get field reference. And in this case, we also return blocked value. Like that. So we have the field reference where object is blocked and field is member. Should rename that one to member then, right? Let's call this member. Field reference member. Member. Does that work? So now we are trying to get the field reference. This returns not a place now, but a value, and yeah, this is a value. Wait, so place expression field. Wait, so how do I evaluate place expressions? That's the question in general, then, because not all place like, yeah, because this should return, because this is blocked. How do I do that? I guess I guess what we have to do is evaluating the place should return so evaluating the place is basically one of the two things. Let's say evaluated place expression. Evaluated place expression. What is evaluated place expression? Evaluated place expression is going to be either a place which is mutable, whether it is mutable and or not, like that. Or it is a blocked value then, right? Or it is a blocked value of a blocked value. And blocked value is going to be a reference in this case, right? Blocked. So it's a reference. Blocked, just so that it's known that it's a reference. Okay, sure. So I open common, evaluate place is this, and similarly to this, I guess then that get field should not be a get field ref. This is going to be get field. It doesn't return a value, it returns evaluated place expression, right? So I don't construct a new reference here for no reason now. I just say that in this case it's going to be evaluated place expression. This is going to be in this case place mutable true field place. I mean, yeah, it's similar. Please forget about it. With return, sure. I will say just place neutral true place. Comma. Class type value. Yeah, so we return not the value here, which is blocked, but we return this. We return blocked like this. Evaluated place expression. Oh, it's ref blocked. Yes. Can I return this directly here? I can, okay. And in this case, we just return get field. Okay, nice. So when I evaluate place here, when I'm doing the assignment, oh yes. So when I'm doing the assignment, how do I assign to a blocked value? Like this must not be blocked, right? So yeah, I need to like match eval match this with blocked error. Can't assign to blocked value. And if it is, so this is a reference blocked, right? And this is a place, which is that. And then we do this. And then I need to surround this with parentheses. Okay. Place expression field, right? So yeah. This is also... Yeah, so now I have place expression field. Place expression field. Okay. Get field of this object. So evaluate place. I need to like match this now, right? Match this with place. Then that. But if it's blocked object, then evaluate place, then so then we also return a new blocked ref blocked shape is going to be a blocked value field reference object field. I guess I need to evaluate this anyway. Have the member type is type in this case ref blocked. So this is a blocked value, which must be a reference though, right? To the place. So should this be type reference? Of referenced is expression type. So this returns place. This returns place. This returns place. This and this return place. This return place. This will return place. Well, I mean, get field returns. Get field returns evaluated place expression, by the way, right? Parent mutability is object mutability. So get field needs to have the object mutability here then, I think. Object mutability. And then that is what we return. From here. Right? Get field. We need to have object mutability. Which is a boolean. So if I have a place, this mut is different, right? I need to return this. Place is mutable. Parent mutability, object mutability, place. Yep. Okay, and then is this like ref blocked object? Wait, but if this is a reference blocked object, yeah, so I evaluate the place. This is an object, which is a reference, right? Yes, I feel like it just means that I need to just rename this from object to object reference, just so that it's obvious. Yeah, get field, object reference. So this get field. This takes a value, which is an object reference, right? Object reference is blocked. Okay. Object reference. This needs mutability. Type reference has mutability, which is mutable. Mutability, because it can be so this mutability is inferable. If I try to get a field, the type here is that the type is a mutable reference. Not necessarily though, right? I don't know. Let's I mean, I can just say new not inferred because, and like, I don't know the mutability here. Evaluate expression reference. Evaluate expression reference. Evaluate expression reference. This means that so I evaluate the place here. And if it is a place, then we do progress. But if it's blocked, then for now I'm just going to return the error and get reference to blocked value. Maybe later we will have that though. Value error, value inferred span. That's reference blocked. Evaluate expression claim. Evaluate expression claim. That is going to be basically evaluate expression claim is we need to once again match this, but this is actually just claiming the reference, right? I can implement that already. So if we have a place like this, then we just claim the place. But if it's a blocked, but if it is a reference blocked, then I will. So this returns the value, right? So this is going to be a new value blocked. Type is going to be expression data type, probably, right? And shape is blocked value claim reference blocked value inferred span. Okay. Evaluate expression assign. Can I assign something? I guess I will not be able to match this in. So I'm trying to evaluate the right hand side of the assignment. That can be in place, not necessarily a value, because we might like pattern match on the left side of the equal sign by like ignore it completely, in which case we don't move the value. If this is blocked, I guess for now I'm just going to return the error here. Cannot assign blocked values. It is not assigning two blocked values, it is assigning blocked values, right? Okay, evaluate expression match. Yes, like how do I do pattern match on a thing which is blocked? I guess I don't do that, right? Well, I mean, maybe we will have the new thing. A new blocked value though. Yeah, I need to do like this everywhere now. With place. Then we do this, blocked, reference blocked, error, span. cannot match locked values. What do I return here though? Does this return a value? Yeah, it does. Okay, value error. Okay. So get field has a different type because now we don't get the object mutability here, right? But I should have object mutability. Object mutability is a boolean, right? Which means that I call it here by saying that object mutable is object reference, right? Object mutable. Can I mutate field reference? I guess I just say true here. I don't know. Span, state, result type, object mutable, value tuple member. Oh, this returns evaluated place now, right? Yeah. So this now returns not place, but evaluated place expression, which is in the common module. Yeah, so now this is not necessarily a place, right? Because getting the field, we might still have it blocked, right? Yeah. Blocked reference. Yeah. So I'm going to match this with place. And now I have mutability too, right? Now I have mutability here, and I have place. So I can actually know that this is mutable now, or not. And if this is blocked, reference blocked, reference, then we just return that reference. This is already a blocked value. Yeah, but result must be value, right? Yeah, so we return a value blocked reference. Value in third span. Okay. Now to the compiler. We cast as module type. Cast interpreter, evaluate place. Oh my god. Evaluate place. Claim. Cast as module type. Cast as module type. Yeah, if this is a type, right? If this is a type, then we can like see if it has an associated module. Right, okay. Let's see here. Match that with place beam. Then we actually claim the place and stuff, right? If this is reference blocked, let's just say error here. Span ref blocked cast as module type. I'm not sure what to say here. All right, success on the compilation. What does this mean? Does it mean that it works? Do you think anything is going to work? Wait, something worked. Right, look at this. So now we have now as part of the type we have fields and the dereferencing. Okay. Wait, and this did not panic. Wait, and this did not panic. Which is weird. This is the example that was not working earlier, but it was written differently. It was written without the dot output. Okay. Let me remove the printlns here so we can actually like check the how this works in the LSP now. Common. This is in subject bindings, I think. Println. Oh, println. Core syntax. Yeah. Can I do here log trace function log trace function log trace function log I mean, this over here is what I'm trying to debug, so maybe we can for now do like info here. Din, 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 din. Although I will actually hide this. Never mind. I will hide this. Okay, let's try to do the language server. So you're saying that it's supposed to work now, right? Restarting cast LSP. No, it doesn't work. Maybe reload the window. There you go. Look at this. Okay. Right. I still have these like normalized for debugging. Okay. Okay. So this seems to be compiling successfully, right? And like running and compiling. Okay, let's see then in this example, right? Can I have let underscore foo is underscore. Let's do not a new type because wait, foo. Do I need to have like the type here now? Interesting. So I have the problem here. It says that value shape dot output is this is not equal to m, which I think is the same issue as I had before, actually. But why was this compiled then properly when I have a new type like this? Right? It just means that this is not a type. This is a function that returns a type. Right? So can I say foo underscore? What's the type here? This is foo this. If I return just a type, which is not a new type, then we should be able to say this properly, right? So this says foo is t, which returns underscore. Why is this underscore here? So I don't know. Right? It should return actually m.output t. Oh, but I don't know what is m output because, yes, because this is the underscore. Yeah, okay. Wait, hold on. Can I, how about I say not foo? What if I say like type of foo? What is the type here then? So this is m, which returns a type. I mean, yeah, this is a function that returns a type. That's right. That is right. Okay, let's try to give it some concrete HKT, right? So HKT is something that has the output, which is a type, which is a generic type, right? Yeah. So how about I say foo, where we have output is TT. Okay, and now we have the problem. Wait, this works. This works here, but my LSP is showing an error, which is weird, because if it runs, then how does it not compile? Maybe I need to restart language server? Yes, if I restart language server, then I see something. But I have a feeling that this is not correct. Right? What's the type here? Wait, hold on. No, the type is also inferred properly, right? Because my output is the original t, right? Okay, but if I say that this is, I don't know, let's say that this should return let's say that this should return type TT, for example. Yes, then this is the thing which has a method foo which takes t and returns TT, right? So because this output t is TT. Okay. Okay. Didn't I see some recursive stuff right now, though? Okay, so the problem with recursive was in the LSP. Yeah, we also don't know what the type of t is. Although, I mean, yeah, I know where the problem is. What if I restart the language server now? You're back. See program lover. Welcome back. Seems like it's working. Okay, but what was not working then? I feel like I want to commit this. This is good. Probably. What was not working is something else. Hold on. Okay, field expressions as blocked values. I mean, this is literally the alternative of this Rust code over here, right? Which implements the higher kind of types with associated generic types of the traits, right? Okay, but what was not working is my original version, which, like, we do this because Rust does not have first class higher kind of types, but it kind of does now with this. But if we try to instead, let me comment that. Let's try the other version of this, which is using just higher kind of types directly. So we're just going to say foo is, so we're going to say that HKT is just the type. HKT is just the type which takes type as argument and returns the type. Type, right? We're just going to inline it here. So foo is m, which is type into type. And then we just have the method foo, which is t unit into m t, right? I'm pretty sure that this was not working. Yes, this is not working. And this one is working. Why? Oh, wait. This one is not a type. This one is a type. That's the problem. This works. This doesn't work. Okay, that's the difference. Okay, but wait a second then. Wait a second. How do I uncomment this? Like that? So if I say over here that this is not a type, then we have a problem. Because this is not a type anymore, right? So this is Rust version. This is cast 1-to-1. Right, and this is like the simpler version, and that works. Okay, so then we can go back to the HKT example of a okay, well, let's first see the HKT functor. So functor example still works. You feel like it's better to have a 1-to-1 example against Haskell? Yeah, maybe. We should have a against Haskell too. But the monad was not working, and it is still not working. But maybe, so like, it's because over here I'm creating a value. Yes. Okay. Yeah, I'm not creating, like, I am specifying the type here, but I'm not creating the value of that type or something, right? For my monads. Like, there's still a bug. Let's say that this is equal and not a colon, right? It says function type cannot be expressed. Can I say type? Function type cannot be expression. This must be in parentheses. This works. Can I have a function that returns empty? So like not the function but the fat arrow here. Huh? What? Just played my game for 20 minutes. Did you like it? Why did you stop? I mean, 20 minutes is also good time. You didn't stop immediately, so it's not too bad, I guess. Reached stage 6. Wait, isn't there like only 5 stages though in the demo? I think there's just 5. Did they publish something on accident that was not supposed to be published on the demo? I don't think so. Where's Steam? Steam. It's not launching. I'm gonna go to stage 6 pop-up shows. Oh wait, so you actually beated the demo in 20 minutes? That's a good time, I guess. Did you solve all of the levels though, or only like you just like went through? Like without any extras. Maybe if you just go directly to the end, 20 minutes. Still fast though, I think, maybe. I'm not sure. Yeah, no, not completing all the levels. Okay, yeah, that makes sense. Because if you complete all the levels, then I think the time is at least an hour for the demo. Wait, what is this? An error occurred while launching this game. Missing game executable. I think I just deleted it on accident. Can I like properties? How do you check it? Verify integrity. I was going to download it. Well, I mean, I don't need to. All right. So is this example also working? Okay, I need to find like the minimal example that is not working. Because I thought that... Well, I mean, obviously if I do a colon here, then it's not working, right? Like this. Like this is not working. Rust is stupid, so many types for string, and int32 is weird. Why not just let int or number be int32 by default? Because you don't have to guess in that case. If it is int32, I'm doing the same here. I'm not saying just int, I'm saying int32. I think that's a good thing. So many types for string. That's on, like... There's reasons for that though, right? Bum 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 bum. Because it's exposing a lot of low-level details, because it's because it has to. Although technically there is not a lot of types for string. There's just two, I guess. The string and the string slice, which is the owned one or the referenced one. The other ones you don't really use, usually. Well, what do you think would be better? Because I'm trying to make, I'm probably going to end up with the same things. Even in C it would be 2 if you wanted to own the string. So right now I only have a single string type, right? But that's probably just temporarily. If we had a... So like string in Rust is the is basically the data in memory of unknown size, which represents the string, which is a UTF-8 thing. I guess it's better to like start with the with slices, not with strings, because for like I guess arrays, there's like 10 different types in Rust too, right? You have T of size n, then you just have T, then you have this slice, which is a reference to T, and then you have like the vec T, right? Does that also mean that Rust is stupid, in your opinion? So when we go to strings, there is no alternative for a fixed size string in Rust, because I guess you never work with fixed sized strings. So the only alternatives are this, which is a string, and this, which is a reference to string, and this, which is a string, right? Although usually you don't work with this direct... I mean, this is a type and this is like a reference to that type. It's not really like a separate thing. So we can forget about this. These are the two types for strings in Rust. Similar to how there's two types for these things. You never used the slice? Well, I mean, you use the reference to slices, right? Yeah, you don't because you cannot have this as the function argument because you don't know the size of it. So when you have a reference to this, this is basically equal to like the pointer. This is pointer plus the size, right? So this is a fat pointer, I guess, right? And this type is like the abstract type, which is only usable behind the indirection, like a reference. Or you could also do a box T, for example, right? Which is similarly to vec, is going to put your arrays onto the heap, but vec is growable, so it also like has the capacity in addition to the length, and this one only has the length, so it's like a little bit a smaller type than this, You know, sometimes it's usable. Also, you can put it behind other things like args, for example, and that is used for strings actually. So you do like arg stir, for example, right? If you want to share your strings between like things, this is useful. But it doesn't mean that there's 10 different types for string. This is the different ways that you can compose strings with other types, depending on your use case. You can get away in a language without needing these strings, right? If your strings are immutable, for example, because the only reason you need this string is in order for it to be mutable, because this is the alternative to vex. Why do you need to have vex if you don't mutate them? Then you just use the slices and box slices, I guess. So we can have a single type for string, which is stir, which basically could automatically mean like box stir, but we don't want, like, eventually if we work with like low level stuff, then we want the boxing to be explicit too, right? So unless you auto box all of your types, which is what a lot of like garbage collected languages do, you need to have at least like the 2 types, which is I don't know, like a reference to string, which can refer to something on the stack in that case, right? Or like, yeah, I don't know how you can do that, because, yeah. Say learned Rust has std ASCII char type. Yeah, I didn't know about that either, because I don't work with that usually. Char. ASCII char. Is that no, this is an experimental API. That makes sense why I don't know about this. This is a new thing, which is not even usable yet. All right, anyway, so we have the problem here with higher kind of types. Why is this not compiling? So I can show you why. It says m is not equal to _0. Why? Why? Well, can I hover something? Yeah, there we go. So like, what is the type? What is the type of foo here, right? What is the type of foo? What is the type of foo? The type of foo is m, which is a higher kind of type, into t mt. Const foo type is type. Who is talking? Lamau? Is someone talking? Did you hear someone else? It's me who is talking. I'm sorry. Don't shut up. Type shape type is not equal to this. Okay, so I cannot specify the type of this, right? That's the problem. And over here, I cannot construct it also because this requires like figuring out this type, and this is okay. Sure. So what's the problem? What is the problem? It says that m is not underscore 0. Okay, so we're trying to specify the type of this, which let's have something in another language, right? Can I have something in another language? Let's say that we were writing Idris. Let's say that we were writing Idris. Maybe. No arrow after closing this on line 18, line 24. You mean this one? No. The line here, the arrow here is not needed. No. It's a little weird. Maybe. Because so like the reason the arrow is over here is because this is like more like underscore of type, you know, that's why. Because without the arrow, this is treated as a pattern, not as a type. But like because this is a higher kind of type, the this basically is not a dependent type, right? Which means that the result type is not depending on the actual value of the argument here, right? But in this case, this is a dependent type because the result type is depending on the argument, right? That's the difference here. So in case of this arrow, this expects just a type here without giving the name to the argument because this is not a dependent one. You love making errors impossible? Hello, Exodrifter. How are you doing? You have been reading on the category theory all of that time, right? You surely understand what a dependent type is, right? Or is that, I mean, that's not part of the category theory, right? But you have complicated feelings about it? Yeah, I don't know. I tried reading one of the books and I just yeah, I don't know. I'm just, you know, I'm just a simple programmer, you know. I'm just going with my intuition of how to build things, even although there is a whole theory behind it. Unless I'm really blocked, I'm going to ignore all of the books. Oh, and your book just has a few errors. You don't think dependent types are part of it because you know, but you know about it. Yeah, it's part of the not the category theory, but the type theory. Yeah. So let me just give this example in another language, which is not my language, which has dependent types, right? Like let's say imaginary Rust, right? Which has where we can do this. So what I'm trying to write here is something like this: type foo is m, which is you cannot do that, right? But let's say that this is m. I guess it's a trait, right? It's a trait foo. It's a trait foo. Where I guess if I do this, then it has a function foo, which is generic over t, which returns this into mt, where this is generic over m. There you go. That's the imaginary Rust here. But obviously Rust cannot do this. which is why we were doing this for M outputs. Why imaginary Rust when you can write it in real Haskell? Yeah, let's write it in real Haskell. Can you do this in a real Haskell? I guess you can. Let's see Haskell, sure. The real Haskell. The real Haskell is what? You have type class foo. Where you have type class. How do you write this though? You should have like type class foo m, right? Which is m is like a star into star, right? And then it's foo where foo is for all t unit into mt, right? Foo is a trait. Well, I mean, in this case is a trait, but I guess we can do it as a, like in this case, yeah. It's just like Rust does not have the traits. Maybe I can just do the type directly too, right? You can say type, foo, m is, if we now we can remove this too, right? We can just say that this is for all t unit into mt, right? Is that how you write it in Haskell? Using star to mean data kind type relies on star is type extension, which will become deprecated in the future. Suggested fix, use type from data kind instead. Oh wait, is that so? In the modern Haskell, you just actually write type instead of stars now? You think the M can be... Yeah, the M can be elided here, for sure. This is more... This is the explicit form, right? Yeah. How do you, like, show what the type is now? But yeah, you can just say foo m is that. Can you say though? Can you elide this for all too? No, like so. But can I do that? No. So like this for all is still required. Issue colon I foo. Yeah. Type foo. Type foo. Okay, yeah, so the type of foo is for all k's. For all k. Why is this k in curly brackets? What does that mean? Oh, k. Wait, k is any kind? We don't know the kind of k? I think this means some kind. K is a kind variable. Yeah. If I do my more explicit form though, like this, maybe, and then I figure out the type of foo. Yeah, then this is a function that takes because in this case I say that the type of k is type into type, right? But it's not necessary in this definition because this can return anything. Because when you declare a type, you don't necessarily declare a concrete type. It can be a higher kinded type, right? Yeah. Makes sense. So yeah, that's what we're trying to do here. That's how it looks like right now. If in Idris, this would look like what? Anyone knows Idris? Type foo. Do you declare types in Idris, like with the type keyword? Sure. I have not tried specifying the types yet. Who? Well, I mean, this is a type, right? A type is like, this is a dependent type, so like there's nothing really different here. We just have a type into type into type, right? That's what we want here. That is what we want. Right? That is what we want. And how do we declare this now? Because that's what we declare, right? This is saying that we have foo m. Go, wait, can you do a lambda? Hold on, Idris lambda syntax guide. Syntax guide. Is there lambdas? Lambda. There's just a list of features. How do I declare a lambda? Let's search using ChatGPT how to lambda in Idris. Backslash, just okay, backslash and then like the fat arrow. Almost like Haskell, but not exactly. So I think it is foo is lambda m into this type. That's what we want here. So this type is going to be lambda. So yeah, the type is a dependent type itself, which is t, which is type into unit into mt, right? That's how we do that in Idris. Let me check. Seems like that worked. Type of foo. So can I just say now? Can I now say foo? And then I give it a higher kind of type, which is like lambda t into t, right? There you go. So this gives me the that stuff. Yeah, I guess like Idris is more similar to my language in that case, where it literally is done the same way. In Idris though, it cannot infer the type of this, I think, right? So you must have the no, you cannot. You do not. Ooh. Yeah, see, this is inferred based on this definition. Okay. Sure. Can I do type ascription though, where m is type into type? I expected dot plus identifier. Can I type ascribe a lambda argument? Yes. Idris lets you type ascribe lambda arguments. Oh, I mean, yeah, it's just before the fat arrow anyway. So we literally just do this. Okay. But then this must be in parentheses, I'm guessing. Okay. Can I have lambda with implicit args? Yes. Okay, so we just surround this with that. Okay. Let's just make it fully like what I'm trying to do here. So I'm doing that, and this over here is also like that. Couldn't parse any alternatives. What do you mean? Maybe ChatGPT lies to me? No, expected dot plus identifier. Lambda x nat. How do you comment stuff in Idris? Double dash. Yeah, this does not work. You lied, it didn't work. Idris 2. In Idris 2, implicit argument must be inferable from usage. But here, x is implicit, x is only used as a value, there is nothing to be surrounded. The rule, implicit argument is determined by explicit ones or by the expected type. What? Couldn't parse any alternatives. But error is couldn't pass any alternatives. Is this syntax anywhere in Idris? Yes, it is. No, the syntax there definitely exists. This is called implicit argument, which is an argument that you don't need to supply when calling a function, which is basically the same as I am doing. I'm just calling them generics, but basically my generics are the implicit arguments, yes. Because you don't need to specify the generic arguments when calling a generic function, for example, right? It's the same thing. The fix, wrap it in parentheses. Now the parser knows the expression is coming. What? Or give it a type plus the liberator. What? The there is parser yelling. Different beast, not better. Was actually wrong. This is valid, but it does not parse in isolation in places where Idris expresses a declaration. You can't guess this is expression. What? I don't understand the... Isn't that an expression already? Explicit case, if, do, application, or operator expression. Interesting. Interesting. I don't... Okay, fine, whatever. We make it using explicit arguments. It doesn't matter. I mean, in this case, I can use the implicit one. I'm pretty sure. Yeah, there we go. So type of foo is that. Wait, this is commented out. So if I say foo t into... Can I say t into tt? There we go. Look at this. That works. I'm not sure why this cannot be implicit, though, in a lambda. So, like, I can specify the type, which is, like, having the implicit argument. I mean, the difference is, like, very... the difference is, I guess... The difference doesn't matter. It's just for me, I don't have I cannot do normal functions as dependent ones. I only do generics as dependents for now, which means that I have to use like the different syntax here currently. But yeah. So in Idris, you just say this. Foo is wait, no, this is a type though. Hold on a second. No, this is a type. This is different actually. Hold on. This is different because this is specifying the function, which is the value of this type. No, it's not. No, it's not. Never mind. Never mind. Yeah. Wait, no. I need to have a type. I need to have a type. Wait, what? Yeah, but this is a higher kind of type, which is not a type. Wait, why am I treating this as a type? Maybe this should not even be doable. Wait, what does this even mean? Because this is a higher kind of type. What's the type of foo? The type of foo is not a type, but this over here, but like I'm saying that this is a type expression here, which means that this is a type, but it's not a type, it's a higher kind of type. Right? Yeah. I mean, this should not even be doable. The error is still weird, though. Or wait, no, the error is not weird. The error is telling me exactly what's wrong. It says that a generic type is not a type. Like, a higher kind of type and a type is a different thing. Right? The error is actually good here. I'm actually reporting a good error in this case. Because I say that this is a type, but it's not a type, it's a higher kind of one. Okay. Debatable. So the correct one is that this returns a type, right? That's what we want. That's what we want. And that... So that's now the thing that returns the type. Okay. Hold on a second. But I have a bug. But I have a bug, right? What's the bug? The bug is when I'm trying to construct the value of this type, right? So when I say... Yeah, right. I cannot say that something is of type foo here. I cannot do the same in Haskell. I cannot say that that something has type foo, right? Because foo is a higher kind of type. Or can I? Can I use this in the type position? THCI. Can I do that? And can I do like ax is foo? No, yes. See, I cannot do this because we expect one or more argument to foo. Because this over here is expected to be a type, but foo is not a type. It's a higher kinded type. Right. That makes sense. That's why I have the error here. Okay. So the bug that I have is when I'm trying to instantiate this with some concrete thing. So yeah, because foo still makes sense on its own. This is probably because Haskell does not have dependent typing powers. No, that's because type and a higher kind of type is different things, because higher kind of type is not a type. Because higher kind of type is a function that returns a type. Function that returns a type is not a type. So it doesn't work it would not work in Idris either. You cannot say over here that X is of type foo. It's going to say, well, process of X, when unifying, right? This is what we expect, because I'm using the type annotation, right? And over here, this is a higher kind of type. Cannot say A is function, yes. I think my bug is when I'm trying to instantiate this with something specific. For example, for example, T, right? Let's yeah. At the type checking level, I don't even need to give it the thing here. And this does not work. Wait, it works? My language server was reporting an error there for some reason. Wait, so, but now it says that T is a recursive one. Wait, what? T is a recursive type. Which is T, which returns itself. Wait, what? Wait, what? I mean, yeah, this is the bug that I have. This is the bug that I have, yes. Let's try to give it the concrete value, right? Let's try to give it the concrete value. And the concrete value is basically like T unit into well, I mean, I cannot do that. I can do underscore though, right? Underscore is of type T. Like maybe I can do here T into empty. So if I say over here X is T into X, right? That's the problem. Why does it type check right now? So this is just T into T, which is correct. This over here, though, is not correct. I think something is, like, being weird right now. T is a type. M is type into type. Are these capturing problems with the two T's? No. There was another issue. No. The fact that they are named differently let's name them differently, right? T1, T2, and T3. It should still work. It runs, which is weird. TT. Like, this over here is weird, right? Because I'm obviously giving it the type annotation that T is type into type. And that does not look like a type into type, right? Something... is wrong. This is underscore into type. Oh, wait. Is it because I'm not... No, never mind. Yeah, the one that I'm returning is that. T into recursive. Why is there... Well, wait. T recursive. Yeah, and normalized is that. Yeah, let's get rid of normalized. Normalized in printing. I'm going to comment this out. Right, so the type here is that this is a generic, we don't know... Yeah, because this is the pattern. Maybe I want to print the type of the patterns, though. When I'm printing the generic, right, I'm printing pattern. Print types. Types true, maybe? Yeah, there we go. Wait, what? Okay, yeah, look at this. So the type of M is the thing which takes a type as an argument and returns the thing which is a generic which takes the argument which is itself and it returns itself. That's definitely wrong. I mean, I know what's happening. I'm just trying to like see the minimized example. Is this because of the way you normalize? Yes, this is because of the way I'm normalizing. The problem is... The problem is that when I am figuring out... Like, I'm just wondering why am I not seeing the error here? Because X is T3, X here is T3. Type. T2 is recursive. Maybe if I say that this is a type. There you go. Right. Right, it's because over here, this was not... Yeah. Okay, because that one was technically working. Okay. And now I'm actually giving it the type annotation. Wait, but why does it... Oh, but I know. It's because this is not unifying the type of the arguments. Yes, I understand now. Okay, I understand now why I was not getting the error. This is going to result in the error, right? Wait, what is not? Hold on. Type is not this. Why not? Can I say that this over here is a type? Please, can you crash already? No, it's not crashing. Okay, well, I mean... Anyway, forget about it. Maybe, like, I was just trying to get the minimal example. My, the bigger example is in the monad over here. Maybe we actually try to do that. Hold on. Well, let's actually try to do that with the monad. Fine. But I will try to minimize this further. The problem is not with the option. I think I can just have the single one like this. So monad which can like return. Right? And then let's have our own foo, for which we are going to implement the monad, right? So there's going to be like t, new type, x of type t. How about that? Yeah, sure. And then we implement foo as monad, where return is just going to be t x into x. So that works. It works because, okay, let's say that const return x is t x t into foo t is x, and then we just return is return x. Okay, there we go. I got it. It's like some annotations are required, right? Wait, but it still runs. Why does it run though? I don't get it. No, hold on. And then the language server is also sometimes showing the errors and then it stops showing it. If I run the monad example, though, it does not work, yeah? In this place. Okay, what's the problem? Maybe... Is the... Wait, oh, is the problem the second one? The flat map, maybe? Maybe the problem is the flat map. Sure. Const flat map foo. Return foo. Flat map foo is t and I just inline this here. Okay, so let's try inlining that here. Let's get rid of the return. We're just going to say that flat map is a and b into foo, which is foo a, and f, which is a into foo b. This should return foo b. Right, and the implementation calculation is that we say that x is equal to f foo x, right? That should be correct. And now I panic. Okay, finally I got it. That is the simple example. That is a simpler example. Can I make this example even simpler though? Can I have this without... without something? How about this? T mt into mt. That is simpler, right? So we just say T foo is foo A, foo T, and this should return back foo T. And we just return foo here. Nice. Nice. Oh wait, I'm running the monad example. Shit, this works. Oh my god. Wait, was I actually running this example though? Previously. Or not? Yes. B is not equal to test foo. Oh wait, hold on. This should just return f foo x. And this works. Wait, what? Why does this work? Why does this work? The problem is the trip specifically? I don't understand my problem then. Let's get rid of option, aesthetic collection, trip. This one does not work. Saying T is not 0. Can I get rid of it? Can I say underscore here, at least? Looks like I can. Okay. Okay. Can I get rid of... let's try rid of the flat map, because that's going to be easier. And that is also not working. Okay. Okay, that is definitely simpler. So this is the thing. Okay, so collection trip. And singleton. Okay. That is the simpler one. Can I get rid of that and just say that T is just empty, or node T, and this is just going to say node value? That works. Okay, so the problem is somewhere else then. The problem is then somewhere else. inside of this code. Where? That one doesn't work. Let's try to get rid of all of these. Let's have just value without left and right. That doesn't work. Okay. Can I say that this is data T? That works. Very weird, very weird. Can I say that? So this one doesn't work, right? This one doesn't work because of the same problem. Can I say right here T? And this is node value. That works. Okay. I know what the problem is, though. I know what the problem is. I'm just struggling to come up with like the simple example. The problem is that when I have is when I'm doing the normalization. When I'm doing the normalization, I have I basically have I'm changing the type like T into T into _0 into _0. So like I'm normalizing my variable names because then I can compare them properly, two types against each other, because type T into T and type U into U are the same types, right? So how do we know that they're the same? Well, we need to normalize them, right? So I'm normalizing my my arguments here, right? Right. But what happens here? What happens here is that we have T into MT. And this over here is also taking M, right? So we have like M, T, into MT basically, right? So the way I'm doing normalization here, let's pretend these are normal functions. T, M into T into MT, right? This is like of some type. If we write this like if it was Idris here. Hello, Major Who. So yeah, how do I normalize this, right? Well, first I am normalizing this argument. So I'm renaming this into _0, and I'm renaming this into _0. And then I am also renaming this, because this is a different function. So I'm also renaming this into _0 because this is a separate function. I'm normalizing this separately, and I'm changing this into _0. And now, as you can see, there is _0, which means that this is a higher kind of type, which takes itself as the argument now, is what we infer based on this. And this is obviously wrong, right? because with the way I'm doing normalization is I'm doing this for functions. I'm normalizing every function's argument separately, right? But in this case, this should be like normalized as a whole thing. So not only the arguments in not only the first set of arguments should be like indexed, but the entire thing. And I guess the more general thing, because like of whatever, we need to be able to normalize like values as a whole, right? Any value should be normalized. I'm wondering if like there is something about this over here. I have not read this at all. But is there like, this is about normalization by evaluation. Program alpha equivalence. That's what we want. Alpha equivalence. While checking simple types, could use type is question mark to compare two types. Alpha equivalence is needed in a dependently typed language because types are programs that can bind variables. Yes. So because we're binding variables, we need alpha equivalence. In the interest of keeping the alpha equivalence procedure short, it does not reject invalid programs. So it cannot be used to check for syntactically valid programs the way that reflects this case could be used for valid simple types. Yeah. The real world checking for alpha equivalence uses more state to track bindings. When a binding form is encountered, a fresh symbol is generated and saved into the target of both sides. Is this like when we're checking only? Because right now, like, I'm converting them to the... yeah, maybe it's like only when I'm checking. But I mean, yeah, we need to do this always. When a binding is encountered, we need to like generate the new one. Right now I'm doing this separately for every function call, but we need to do it as a whole for the whole program. Yeah. When is this being called though? Alpha equivalence. Convert a neutral expression into its representation as a syntax. The only case that is not immediately the same as others is for int absurd. It has the type notation. The original case in alpha equivalence calls all initial inhabitants of absurd identified to one another. Check whether v1 and v2 represent the same t. I cannot read this. I don't understand. I need to read this fully then. I'm too lazy for that. But yeah, I understand the problem. And the way I'm doing it is not correct. Yes. Substitute bindings. No, not substitute bindings. It's in the interpreter core. Right? When I am creating the generic type for now, I'm doing the normalized things. But that's not when it should happen. Well, I mean, let's pretend that this is the only place where it is happening, right? I'm just saying that the result... Convert, perhaps C, okay. Check whether two values represent the same t. Why is there the t? I don't understand what this means. Convert. Where is the convert being used? The type checker. Elaborating type checker. This means instead of simply indicating that an expression is well typed, it returns a version of the expression with more details inserted. In other words, the language accepted by the type checker contains structures that are not understood by the normalizer, and the type checker emits expression in that simpler language. In an elaborating bidirectional type checker, check-in emits an elaborated equivalent of the input expression. While examining types, looking at specific type constructors, type checker matches against their values. To ensure that the type checker never gets to normalize before checking. Which could lead to types that contain unrealized computation not being properly matched. I don't understand these words. Alright, let me just close this. I think what I want to do here is I want to like, how do I normalize this properly? Right? How do I normalize this one properly? Right? That's my type. Right? So I am changing this into _0. Right? Yeah, the thing is, like, so here's what we know. Here's what we know. We know that this over here is already normalized. That's what we do first. I think, right? So like I change this into _0 and this into _0, right? So as a next step, before changing this into _0, I need to like increase these things. And I need to like change this back to _1 because I'm adding one a new binding. And then I can replace all amps with _0s, right? I cannot do it the other way though, I guess, right? I don't think I can do it the other way. I don't think I can keep this as a 0. Or can I? Wait, I actually can, right? Like if there are certain amounts of things there, but that means that like doing that requires knowing how many things are there, which is something that I cannot do always because some of the things aren't inferred yet. Is the problem. We can also do this just only when type checking though, I think, maybe. Like right now I'm trying to always store. Right now I'm trying to always store the normalized version, but maybe I don't need to do that. instead when instead, let's say that we have empty like this, and then I have like, I don't know, let's call this AB, and this is like AB, and then I have like C, D into CD, right? I need to like know that this is the same.
Nice microphone you have there. Who recommended it to you?
Did you hear this thing through the microphone? I removed my noise gate and stuff. Yeah. Is it nice? I'm not really listening to myself. Beautiful. Okay. Good. Let me know if there are any issues. All right, so what I'm trying to do is I'm trying to see that that these two are the same type, right? How do I do this? Maybe we just do this during the unification. You know? Yeah, maybe. But that means that unifying the types requires extra context. Right, yes. Requires extra context. The context is how many... The context is how many symbols have I already replaced. Right? Right. I think that's... yeah. Let's try that. And then I don't need to have the result normalized here. I say that my generic type is literally the... like, I'm just doing the result normalized here. This is completely useless then. Let's try removing this. Wait, did I remove too much? What just happened? Everything from here to here. That's what I'm trying to do. So just argument and result without the result normalized. So type generic is going to only have the argument and result. We don't store the normalized version here. We will do it during the type checking. Maybe. So over here, this is the this is the type checking. This is the type checking. So how do we figure this out? How do we figure this out? We need to unify these things given the current context. Is this inside of some implementation? Like, don't I have some unite? Don't I have some context here? I guess like right now the unification does not have any context at all. Inference unite is just like this thing. It does not have any context. But I must give it some context. Let's do this. Let's say type context is yeah, and we will like just generate new symbols. Right? So yeah, like so we have the, like normalized bindings. It's going to be a map from a binding. And bindings, they just have IDs, right? ID map into binding. And then we have effect. Type. Effect. What is HKT stuff? Higher kinded types. I just don't know what to I like to actually write here. If you're wondering what I'm doing, I mean, right now it's not even like higher kinded stuff. It's more like dependently typed stuff. But higher kinded types are like a special case of the dependently typed things. Basically, we're doing the type checking. And we need to check that two types are the same. And because when we have higher kinded types or dependent types, we basically have functions in the type system, right? It means that the type can contain a function, which means that it contains the variable names, right? And when we are doing the type checking, the variable names can differ because the type was declared in two different places. And because the names can differ, we need to normalize the names, right? This is what a binding is, right? It's just like a name of a variable, basically. So we need to, when unifying, we need to see that, like, if in a type 1 there was a variable, then it should be like if we rename that variable to something else, then it should still be the same type, right? So yeah, does that make sense? That's called alpha equivalence, I guess. In lambda calculus. Alpha conversion captures the intuition that a particular choice of a bound variable in an abstraction does not matter. So the term, like, so when you have lambda x m and you have lambda y m, they are equivalent, right? So when you have a function that takes the argument and it names the argument x, and you have a function that takes the argument and names the argument y, the name of the argument doesn't matter. That's what we're trying to check. So during the type checking, we are going to basically maintain the current like bindings when we encounter them. We are going to, because the type checking happens in parallel in both places, we are going to encounter the same like the similar bindings in the same at the same time, right? So then we will like basically substitute them to the common name, and that's it. So for the generic specifically, because that's the only dependently typed thing for me right now. So we have two arguments, right? So two arguments, this is the arguments. These things are patterns. Patterns are the things that introduce new bindings. Right? Right. So first of all, we need to see that these patterns are equivalent. Which also like makes me think that there is another problem, right? Let's say that I have a function. Let's say that I have a function which takes x and y and returns, for example, x plus y, right? This function is equivalent to the function that takes a pair and returns pair dot 0 plus pair dot 1, right? But in this case we have two variables, and in this case we have one variable, but the function is the functions are technically equivalent still. You know? Maybe I just ignore this case for now. Maybe I'm just going to ignore this case for now. I'm actually wondering if well, I mean, one of the things that we can do is we can try to unify the patterns, though, right? So, like, when we say see x and y as one pattern, and we want to unify this pattern with a pattern that's called pair, right? It means that we need to have all the three bindings now in our thing. Yeah, I think that's all. We need to like we need to somehow like unify the patterns basically, which I'm not doing right now, right? Yeah, that makes sense. So unifying the patterns, in case one pattern is taking the name, is having the variable, and another one does not have the variable, it just doesn't do anything basically. We only need to unify like the variable names if both names exist. Wait, no, that doesn't work because then like over here I need to know that pair.0 is equal to x. Yeah, I guess it's not that easy. Well, I mean, it is. Wait, hold on. It is. It is. So when I'm... Wait, hold on. So, like, the way this works here, basically, the way this is going to work... This way this is going to work. We have a pair here, right? And over here we have two things. In this case, we have a pattern which binds a variable, and we have a pattern which like destructures the pair already immediately, right? What we're going to say is that pair is going to be replaced. We don't just replace the binding, we replace the pair with x and y. That's what we do. That's literally what we do. And then when we are normalizing this, we are doing, once again, we're doing normalization by evaluation. So when we say .0, it is going to automatically be evaluated to x. And so we will know that this is equal. This actually makes a lot of sense now. Yeah. I think I understand how to do this. But it means that... It basically means that type checking like this Like when I'm unifying these two types, how about x plus y and y plus x? That's a different thing. X plus y and y plus x is something that needs writing proofs, I guess. For now, we don't think about it. That's a separate feature, I think. Yes, that's a separate feature. That is a separate feature. We don't think about it yet. Because I'm like, that's not something that is automatically inferred already. That is something for which the programmer is going to write proofs. It's about the associativity and the underlying type plus operation. Well, the way it works in like these dependently typed languages is like you say that x. So like when you see plus, usually you need to like prove this for like integers usually. So you like specify your type like integer, they call them natural numbers, which is either like a 0 or like the next number after the existing number, right? So then you like write some proofs by induction, by first saying that 0 plus 0 is equal to 0 plus 0, right? So like in this case, the associativity is obvious, and then you like do the proof by induction. I don't know, like I feel like looking into the proofs is something that I'm going to do later. I don't need it right now. I'm not doing full dependent types yet. Just HKTs. Did you hear about Lean language? Yes. There's Lean, there's Idris, there's a bunch of others. I guess like Agda can do the same, Coq. Right? Boom, 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 boom. So yeah, basically dependently typed language includes the ability to do proofs. But yeah, what I was saying here is that when we are doing the type checking here, when we're doing the unification of these two things, I'm automatically saying that pair is this. I'm going to substitute that. So this is already at the evaluated value. Yes, yes. And I'm going to evaluate this. Yes, yes. I'm just going to substitute. And substitution is going to lead to evaluation, to further evaluation. Maybe I can also like make a simpler version right now which doesn't do this. Let's do a simpler version. Let's do a simpler version. There needs a way of destructuring by default. I do have a way of destructuring already. Like you can literally write these two things already. Yeah, right now inference is not invoking evaluation at all, but yeah, I would need to like restructure too much to do this right now. So let's do this simpler version where we just have the context, we just have the normalized bindings, and we don't like do anything else. Okay. All right. So we just we still will have something which is called unify these patterns. Right? Unifying these patterns in the current context is going to like do I fork anywhere? I don't. That's good. So I'm just going to say unite pattern arg A and arg B. I mean, yeah, we just do the unification here, right? Unite pattern span arg A and arg B. Sure, and the result then is just so I literally just do the same. Unite. So these are types, span, result A and result B. Then the definition here is going to be really simple like this. I just need to specify what is unite pattern. So this is pattern inference unite is function span. We have pattern A and we have pattern B. I'm just going to return A, but we are going to go over the patterns, and we are going to unify the bindings there, right? So we're going to match A shape and B shape with. So we have patterns. Let's see, pattern error and pattern error is just whatever. Pattern error and pattern error. How would I do this? Also, fail is error, error. Span. Patterns cannot be united. This and this. Print pattern A, print pattern B. So here's all the different patterns that we have. If we have placeholder and placeholder, then it's okay. But if we have placeholder and something else, we will actually fail. If we have okay, unit and unit. If we have unit and anything else, then we fail. If we have error and error, then this. If we have error and anything else, then we also fail, I guess. Okay, if we have a reference pattern A and I have a reference pattern B, all that we need to do here is we need to... I mean, I can also just return this thing, right? Yeah. I guess in this case we just return A. So this returns pattern unit. Oh wait, I cannot return like this because that we don't only have the shape. Forget about it. Forget about it. Or wait. Well, I mean, yeah, we have like a lot of data there. I don't think I can. But I for sure need to unify the types of them, right? So I need to like unite types. A type, A data type, and B data type. But we just ignore that, I suppose. Okay. So we have a reference A and reference B, then we just unite patterns. Maybe uniting the pattern should be something that is not returning the pattern. Maybe this returns unit, so let's just have a function that's like span pattern and unit. Then so I don't return it even, and then I say that argument is we unite them, but then we just use the argument A here. Yeah, and then we just, in this case, we just unite pattern AB. If we have a if we have a reference and anything else, then we fail. So the binding is the interesting one, right? So when we have a binding A and we have a binding B, this is where we need to do something. Okay, if we have a tuple, pattern tuple, parts A and a tuple, then so this is a list. What does list zip do? In case combine, invalid list combine. Yeah, okay. Like I need to basically check that the shape here is exactly the same. These are the lists. These are the lists. Let's have the variants first. Variants are easier, I think. Pattern variant has a label, span, and value. Label is label A. Label span can be ignored. And we have value. And we have a variant. Label is label B. Value is value A. Label span can be ignored. Value is value B. So this can only happen. This can only happen when label equal. I mean, we have label unite. Does label unite check? Try uniting different labels. Yeah. Do I actually unite this? instead of checking, maybe let underscore label is label unite label A, label B, and then we just say that. So now we'll have values. Values are optional patterns of like the inner values associated with the variant, right? So I need to match now value A and value B, right? If it's none and none, then it's okay. If it is sum A and sum B, then we need to unite patterns A and B. And if it is sum and none, or if it is none and sum, then we also fail. P variant is only potential, non-exhaustive type of a pattern. Yes. Yes. We don't do exhaustiveness checking yet either. Well, I mean, it also means that right now I'm probably not using the variant types in patterns of functions, right? In the arguments of the functions, I probably not doing that. Although, like maybe you could write a function which takes, like, you know, like if we have a type either, for example, right? Then we could have a function that takes like left x or right x, and then like returns x, which is basically unwrapping the either where both types are the same. You could write something like this. Although right now I don't allow the OR patterns either. I have not implemented that yet. So, yeah. But this was easy to write, so it's okay. Now this over here, we have patterns. We have tuples, which have a list. Right? And this list. This list. Let's also do the simple stuff where, like, for example, tuples contain the named arguments too, right? So if I'm trying to pattern match A and B, and in the other pattern I'm trying to pattern match B and A, technically this is the same pattern, but the order is different. But let's, for now, for simplicity, say that I'm going to like say that there's an error here, right? For now, I'm going to say that this is an error. So we're just going to literally say that every part in the same order should be present. Okay? Yeah. So we just say latrack check parts A and B, B something, and I'm just going to check parts parts A and parts B. So over here I'm just going to say that check parts A, B. We're going to match A and B with, if it is two empty lists, then we just don't do anything. If we have empty list and not empty list, or not empty list and empty list, then we're just going to fail, right? But if we have add a tail A and had B tail B, impressive, I have the flu. Is that impressive that you have the flu? Because you never had flu before or something? No, you are impressive. No, you are impressive. Get well though, I guess. So we have had A, tail B, right? So we are going to check parts tail A and tail B. But before that, we have had A and had B. We're going to match had A and had B. We're going to match had A and had B. Fail. Should fail also like let exception E. Let exception fail. I think I want to raise fail here. So that like we don't continue at all. So I'm just going to try with fail. And then we just don't do anything. We already failed. Or am I going to like check the other parts actually still? I don't know, maybe we don't do that. So we actually check the other parts. Forget. After you sipped from your CP cup, you became 2x impressive. And to go get more water. Had A and had B. These are the parts of the tuple. Wait. A list. No, it's a tuple part of. It's a pattern tuple part of list. And B is another pattern tuple part of list. So this is tuple part of, which is either field or unpack, right? So we have if we have let's start with unpacking A and unpacking B. Then we just, so these are just patterns, we just unite pattern AB. Unpack, and this is going to be fail. I guess I'm just going to get like multiple of the errors in the same place, but whatever. And I have field A and field B. In this case, what do I do? Tuple field of. We have label, label span, and field, which is very similar to the variant here. Field A. Label B, field B. So yeah, first we say that we unite the labels, just like over there, and then after that field A and field B are two patterns, so we just unite patterns, field A and field B. Okay, so that was the simple part. Now to the interesting part where we actually see the binding. When we actually see the binding in the pattern, we need to make sure that these two bindings are the same bindings, right? Pattern binding has binding and it has by ref. Well, first of all, we need to see that... let's do by ref is by ref A, binding Z, the binding B, by ref is by ref B, binding is B, when by ref A is when boolean equal by ref A and by ref B. Right, so in this case we have two bindings. This is where we get the context. Context is effect perform get context. And context has the normalized bindings. This map must be mutable. So we mutate the context in this case. Context, normalized bindings. So we can change any bindings to any other bindings. It does to any other binding. It doesn't matter, really, right? So normalized bindings is context normalized bindings into ID map add. So I add to a ID. I'm adding like binding, and I add to BID also binding, where I'm just going to say that binding is A, right? Like it doesn't really matter which one we use. We can also generate a new one, but it doesn't matter. Like, why do I need to generate a new one if I can just use one of the existing ones? Yeah, why are they generating the new symbols if we could just like, I mean, it doesn't matter. Literally. So I just do that. Oh wait, the labels are optional here on the fields. Oh my god. Match label A and label B with none, and none, some and none, or none and some other than fail, some A and some B, then we unite the labels. Okay. Casting cast when? Not this year. Next year probably. Not sure if I'm going to work on Linksider first though. I don't know. I mean, trying to just we're going to start with Lexer anyway, right? So maybe we can try the Lexer relatively soon. If my type system is finally going to work properly. Um, oh wait, that's a nice error. Oh, camel, unbound module error. In the file none. Print pattern has type option. Print pattern. Am I not printing patterns? Oh, this one is actually not being used. I see. Let options be options print. I mean, let's just say that let print pattern be print pattern options this types is false, spans is false. That's all. We don't print any of those. What is this? This is substitution. Now when I'm substituting argument results, we just do that. That's simpler now. Compiler. Can ignore that. Okay, success. Success of the compilation. Is it going to actually work properly though? Oh, we now have yeah. I have unhandled get context. So yeah, because I have written this. So now my inference requires the context. We're going to say over here something like we are going to say module impl is struct. Is this all recursive? I just want the unification though. So like this. And can I say over here let track? That's going to work still. No, inferred value is required. Okay. Fine, let's make all of this in the recursive. After all. Well, I mean, actually, no. Hold on. No. I want only the unification. It just means that... No, but this actually, yeah, when I create the new one, it also requires unification. Shit. Okay. I actually have to make everything here like this. Recursive. And now new not inferred type. new not inferred type is Rudy was found. Hey kid. Who, me? I'm a kid. Yes. Hello. Hello, Dad. How are you doing? You're old. Hello, Grandpa. I use Windows, by the way. Oof. New not inferred type. I just need to like expose everything, like by wrapping that in the thing that provides the context, basically. Right? Yeah. So new not inferred type. Windows because of Cyberpunk. I have a friend who runs Cyberpunk on Linux. Isn't Cyberpunk like a single player game? And like the only problem with games on Linux is if they require anti-cheat and single player don't have them. So like why would it not run on Linux? I mean, I don't know, maybe there is a reason. For some reason, but it has been a while since I have tried playing something that doesn't work on... You don't have Linux mainly because of NVIDIA problems? I see. Is impl.new not inferred type. Span. It's very similar to this. But all of these arguments have different types. They all have the span though as the argument, I think. So maybe I can, if they all have the span as the argument, can I say that let with context, so I'm going to say with context here, with context, f is just going to be a function span into f span. But we do this by trying that with fx get context. Okay, fact continue. Okay, context, where context is normalized bindings is id map empty. Right, like this. Do you like convert your balcony to a room? I mean, I didn't really need to do much for it. It's not really converted other than me bringing the furniture here. And like in terms of furniture, we just have the table and the chair. So the conversion was simple. All right, and now I just like need to export all of this, right? So inferred type is impl inferred type. Yes. Type of value shape. Type of blocked, I guess, can be extracted. Init place, I think, can be extracted. Wait, init place. Oh, wait, I actually have this here, which is weird. And type of blocked is used. Type of value shape. Value shape. Okay, fine. Let's keep everything here. I'm just going to do that, right? Let type of value shape be impl type of value shape. New not inferred value is with context impl new not inferred value. Then return value of type with context. Inferred value with context impl inferred value. Can I like somehow just get all of the things here? I guess I can do like end. Yeah, maybe I can do end. There was one end. Can I do end like this? There we go. And then I can do copy, open. I cannot open because I need to wrap everything with the context, right? So yeah, I guess I could write like the preprocessor to do that maybe, but I think this one is going to be easier. We just say like this: let this be with context impl dot that, you know. And like some of these then are like unite option, for example, but I guess unite option is not really like used on the outside. And these things, type of value shape, these don't have the span, so I can't, these ones are not like this. Such beautiful code. Yeah, please use NeoVim, come on, oh my fucking god. Okay, if you say so. If you say so, let's go to NeoVim then. Alright. Let's do that. Stu squared. Hello, hello. Thank you for the raid. Welcome, guys. How are you doing? How was your stream? What were you doing? You didn't end the stream yet, by the way, but thank you for the raid. Working on some game, I think, right? Is what happened. A ROM hacking text adventure. Cool, cool, cool. All right. What is that? Activate Linux? It's just a watermark, which means that my Linux is not activated because I'm broke. You want that? Just get broke so that you cannot afford the Linux license. It's that easy. You know, just stop working. Like you go to job every day, just stop doing that. Oh wait, I do have unite option. Wait, what? Unite. I need to have unite option. Okay. So unite option is the thing that is not using. It is still with context. Impl unite option. But impl unite option has also a inference unite as the first argument. So unite option, unite value is with context. Impl unite option, unite value, like this. And then it works. Hello, Pigorly. How are you doing? Okay, so it is successfully compiled now. Is it going to work? Is this going to work, though? It is still saying that it has the unhandled effect. But unhandled effect is happening from within uniting pattern. So the problem is... that we are leaving the functions here. So we were probably using like something like once inferred. There you go, once inferred. So once inferred is the thing which runs this function once this variable is inferred, which can happen later where we are no longer inside of the context. Yeah. When we are no longer inside of the context. Wait, but don't I just give it the new context here? This is for just the new not inferred values, right? This is the only two places, I think, where this is happening. For new not inferred values. Is new not inferred values used anywhere else inside of the inference? Not really. I made a particle simulator in C++ and OpenGL. Can I send you GitHub repo to check it out? Sure. What am I going to check out there? Not sure if I want to be building C++, though. Hi, I was solving the Cinecore challenge. The Cinecore challenge? What is that? Advent of Code? Something similar to Advent of Code? The website is not opening for me right now. But I guess it's something similar to the Advent of Code, right? Arch spec. Is this implementing the virtual machine or something? I don't know, the connection timed out here. You build a virtual machine and extract inject assembly, so you are building a nicer model of instructions, prepping for decompiling. Yeah, I'm not sure what the challenge is about because the website is not opening though, but sounds cool. Sounds cool. The goal is to collect 8 codes that you can enter on the challenge website to track the progress. Can I do that in my own programming language? Is the only question that I want to know. It's like Advent of Code. Cinecore challenge by accident. This coding challenge was created by Eric Wassel as well. Oh wait, this is by the creator of the Advent of Code, right? It's the same person. The goal of the challenge is to collect 8 codes you can enter to track the progress. It's just that the challenge website is not opening for me for some reason. Does it work for you? It says that the challenge page is down. It's like the old thing, right? And here's the copy that someone had. All right. There are a bunch of things like Advent of Code. There was one other one. There was one that is called Advent of Code by L:Q, right? Is another thing that I was thinking about. But the part 1 here has like 60 rules or something, 67. It's some yeah. PCOM is blurring the activate Linux thing and you cannot exclude it since it's not a window. Anyway, hold on. Yo, Togglebit, hello. Toggle rate. Welcome, guys. Togglebit. Hi. How are you doing? Welcome in, everyone. I'm trying to work on my programming language. And we are in some higher kinded types and dependent type territory currently. I'm trying to fix some bugs. If you come here for the Linksider, that's the game that I'm working on, but I'm not working on the game right now. I'm going to work on the game more next year, though, in January probably. The game is written in Rust with a custom engine. Since Togglebit was doing Rust, I'm assuming. You guys are fans of Rust, right? Mostly Rusty, yeah. the language that I'm making, I'm not making it in Rust. I was making it in Rust before, but then I decided to rewrite it because I hit the performance, not the performance, the compilation times were literally killing me. I was having the rebuild times in Rust of more than 1 minute for the smallest changes, so I decided to rewrite my language in OCaml. And here we are. I'm actually like pretty close to starting to like try to write the self-hosted version, I think. You're lagging like 5 minutes behind on audio. Is anyone else 5 minutes behind who has said something in chat? I guess it's just on your side. It's 2 squared. Test, test, test. The audio is fine. Yeah. Okay. Yeah, thank you for the raid again. Alright, so we are right now doing what? Let me show you guys a little bit of the things that we are working on. So here is my test. So Rust does not really have higher kinded types, for example, right? But Rust has a generic associative types. And generic associative types basically allow Rust to have higher kinded types. Actually, wait, is there anything that Rust cannot do with generic associative types that higher kind types can do? This is a relatively recent addition to Rust, but isn't that unlocking everything that higher kind types can do? So yeah, you can higher kind type is basically like the function that returns a type. So in Rust you mimic that by having the generic associated type, because generics are basically functions, right? So that is something that allows you to implement monads and stuff. And I'm just having right now the problem where I'm not type checking things properly. Specifically, the problem that I'm solving right now is how do we unify the thing that has generic types, right? So let's say that we have let's first say that instead of having this over here, this is a trait foo with this is trait HKT with the generic associated type that is in Rust, right? So you can just say instead that HKT is a function from type, and that returns a new type, right? That's basically what this is, right? And then this over here is a foo, which uses this higher kind of type as an argument, right? So foo is the thing that takes m, which is the HKT, right? Which is type into type. And then this returns the new function, which takes t, which is a type, and then returns the this higher kind of type applied with the with this t over here, right? So in a like functional programming languages, you usually like call the functions without parentheses and stuff. So let's say that this is the syntax, right? So when you look at this, the important part here is basically that the result type of this function depends on the argument of the function. So we must not only provide the type of the argument, but also the name of it. So we are introducing a new name in the declaration of the type. That's what makes this a dependent type. The result depends on the argument value, not just on its type, right? Because we are over here literally calling the function that we give as an argument to this type. So higher kind of types is a special cased dependent type, basically. So the problem that I'm trying to solve right now is to do the type checking of two things which are the same, right? Let's say that we have function which takes this, and then we have the other function, but the other function is like renaming this argument, and instead of calling this m, it's calling it m, right? But these types are still the same. You just renamed some variable. So that's what we're trying to solve. We need to make sure that the types are the same. And renaming a variable does not make a type different, right? So this is my task right now. So that is normally not happening in non-dependently typed languages, I guess. But in dependently typed language, we are having types which introduce the new variables, and this leads to like this problem. Yeah. Okay. Let's do the actual work now. And what's the work? Yeah, I have some like unhandled effects right now. I think I'm almost done. So here's my inference implementation. What I need to do is I'm losing the context over here. When I'm creating the new not inferred values, I'm saying that once it is inferred, I need to do something. And I guess over here I need to give it the context. Yeah. Let me move with context over here to the top. Like over here. And then once inferred, must do that by saying with context that's what I'm doing. With context infer value shape span new not inferred value of type infer as. Can I over here say with context function span into that? What's the problem here? This expression has type span unit, but expression was quite of type unit. Oh yeah, and now I need to like call this with span. Not here. Over here. And it still doesn't work. We still have unhandled effect. So I'm using OCaml's effect system, which is like a resumable exceptions, and it's not present in the type system, which makes it a pain figuring out where this is happening. Once inferred. So it's not once inferred. Anything else? Anything else here can do something bad. If I look at the stack trace here, so I mean this happening when I'm compiling the core constant stdcmp. While initializing expression at stdcmp to stdcmp line 2 to line 7, this over here. I don't know. What about init place? That's fine. Blocked. That is fine. How come I don't have the context? I want to see any function that is created. Like for example, over here, I'm going over the tuples and I'm calling this function, right? But this function is being called immediately, so that's not a problem. Like, what can happen? So like, when I call these functions directly right now, I have the context in the scope, but then there is a potential to escape the scope where the effect handler is present if I have a function which is going to be called later. So this was one of the places where this could happen. Inference variable once infer, so this is like just registering a callback to be called later. But now I'm reinstalling the context, so it should work. The only other functions that I see is the tuple mapping, but that is called immediately. Can maybe let's take a look at the other inference. So the inference core is over here. Do I create some functions here? I don't know how to debug this. How to debug the fact that my effect handler is no longer present. Right, what we have is the unhandled effect, which is similar to unhandled exception problem. This is raised by the primitive called unite pattern. Oh wait, it's inferenced. It's by unite pattern. Unite pattern is because of unite type generic. Unite type generic, because we're uniting some types, because we have the expect. Cast inference expect. Maybe I'm not installing the context properly. Like I'm just saying with context, f. This introduces the context. Oh, wait. Yeah, that makes no sense. Yes. So, like, yeah, this is actually incorrect. So, I am I am returning the function which is partially applied. So, I'm going to provide the rest of the arguments after the effect handler is gone already, which is not correct. Okay. How do I like wrap the function with any number of arguments in the effect handler in a generic way though? Because otherwise it's going to be really annoying. Is that possible? Is that possible? Like I can wrap the functions with a fixed amount of arguments. Can I check that that my like argument is a function and basically like wrap the function until it's no longer a function or something? Is there like OCaml object like object representation? There's isBlock. I think I can check if the function is an argument, right? If the value is a function. Okay, but a lot of these unify functions are basically having this type, this thing, which is basically like type, shape, inference, unite, right? Yeah, maybe I can do with context. With context, f. Well, let's just call the function f with the context then. Like this. But then I will say unite with context, where f is like some unite algorithm. And then we do... Then this is going to have span, and then a and b as my three arguments. And then I do with context. And then we have a function which calls original f with span a and b. Right? Okay, so now this doesn't work. So all of these unites. This is going to be like unite with context. unite with context. Let's just change all of this. Unite with context. Some of this is not going to work though, right? Because for example, unite pattern is the function. Wait, what? Unite pattern has type span pattern, but expression was expected of type span pattern. Yeah, because this one is doing the unit. So I need to do it carefully here. Span AB is with context function unite pattern span AB, right? Well, I mean, no, whatever. Let's do that. Okay, and then we have inferred type. Inferred type is just having type shape type. So this is going to be with context function inferred type span shape. Inferred value has span and shape too. Infer value shape also has span and shape. This over here is, by the way, one of the reasons why I don't like carrying. Unless I'm not aware of a way like I basically need to make sure that all of the function, all of the arguments for the functions are applied, right? But when you have carried functions in a functional programming language, where you have a function, returning function, that's how you do multiple arguments. Then how do you guarantee that all of the function arguments are applied, right? That makes it a pain and bug prone, as we have just seen. Yeah, if it was not carried, I would just apply it to like the single argument, right? Like, because what I want to do here is I want to like wrap every function into like, I don't know, like let's say that I want to wrap every function into like there's a lot of things that we could wrap the functions, right? We can wrap like with logging, with like measuring time, for example, for profiling. And I cannot do that like automatically very easily. In this case, I'm installing the context for unification, but like... And if later I add an argument to this function, I'm not going to catch the bug either, which is also very like weird. Well, I mean, I guess I can catch the bug if I like make sure that this returns a type. Like, but then I need to like write the type here too, and I cannot rely on inference anymore. You know, like this is a function that should return a value. right? So I'm like making this type annotation here so that we know that we are not returning a function which is partially applied. Hello, Betseg.
Hello, Betseg.
Hello, Betseg. Your anti-Orny car with that stream title. What's Orny car? That's not a word. You just came up with that word. Wait, there's a Wikipedia page about it. Orny car. I cannot really read this, and there is no English page here. He's the Lichess creator. His stream titles are writing bugs for Lichess. I mean, we need to like remove some bugs, then we are going to add some. Don't worry about it. Okay, now is this going to work? Line 475. Wait, what? Oh yeah, because now this is the now this is with context. Now we just do that. Yeah, there we go. And now I don't apply this, which makes it easier actually. Yeah, and this is going to be unite with context. All right. Now, please work first try. Blocked value shape t is not equal to t. Okay, that's a good error, right? T is not equal to t. Everybody knows that. Haven't gotten his notification in a while. I think I saw someone who is like working on Lichess. That's probably was all like Orny car, because probably there is only a single person who is working on Lichess on Twitch, right? Okay, so the problem, I think I maybe did not do something, because when I unify the bindings, that's what I need to do. And we have blocked value binding. There you go. This over here. So now, when I'm checking two bindings, I need to do things, because now their IDs might be different, but they might be still the same bindings. Because in the current context, we have merged them by merging some other patterns, right? So we say context is effect perform get context, right? Twitch Android being Twitch Android. You also need to like, there is also some settings. I have two Twitch accounts and I'm only getting notifications on one account. Context is context dot normalized bindings. Yeah, so we have normalized bindings. And I want to say that A is context normalized bindings. ID map find opt AID option unwrap or else You don't get notification from my streams either, but other streamers sure. There's this button over here, right? Where you're following someone. And then over here, you can have personalized, whatever that means. Or you can have like always, or go live only, or off. That's just like separate for every streamer. Right? Yeah, I don't know. Maybe it's Twitch problem. Or maybe you need to do something in the settings, I don't know. Can I like say that let normalize binding is I basically want to do this, right? Match normalized bindings, find binding ID. If it is some normalized, then I return normalized, and if it's none, then I just return the original binding. So we just say then that A is normalized A, and then B is normalized B, and then I say that if A ID now after normalizing, if not ID equal A ID and B ID, then I fail. Otherwise, I actually just return the thing. Yeah. Mm-hmm. And it didn't work. It still says T is not equal to T. T is not equal to T. I want to go back to VS Code. Because in VS Code we have this option, which I don't know how to make work in the in NeoVim yet. We can click on this T here and we can go to the definition of it. So this T and this T, these are two different T's, right? This is the T that is defined over here, and this is the T that is defined over there. Yep. That makes sense. These are indeed different T's. These are indeed different T's, but why? Are they different? Like, didn't I unify them when unifying the patterns? Inference simple. All right. I will need to end the stream soon, I guess, but what's the problem? I thought this should have fixed it. So I'm trying to unify two things. This included unifying two generic types. And I was uniting the patterns here. And uniting the patterns involved, and like we are supposed to not delay anything anywhere, right? So I'm adding the A and B both to be unified into that binding. Which is one of them. How about I say this here? Let's do this. Let's do print unified bindings, this and this. Binding, print binding A and print binding B. Well, as you can see, I have unified T and T. This T and this T. Wait, what? What is this T? Wait, how is these? Wait, what? How is that one not having the link? It's underscored even. But yeah, nothing. Not nothing. Or is it nothing? Wait, nothing on the right. Wait, what? How is this possible? Nothing on the right is clickable. That means that there is a bug. So I'm using the OSC8 like thing so that we can click things in the terminal. But for some reason, this does not work. On the right here. It works here though. These are both clickable and both lead to different places. How am I doing that here? That's just printing the bindings. Printing the binding. We just print the span. And the span should be printed, you know? Okay. How about I do like add this and this, add this. I'm going to print binding A, and I'm going to like span print A span, and then I print binding B, and I span print B span. Let's see, explicitly print the spans. Right, so the last things that I unified is this and this. Wait, is it because they are both the same spans? Wait, why am I unifying the same ones? That makes no sense. Wait, hold on. Why am I unifying the same ones? I'm always unifying the same ones. There's something wrong. Unite pattern. Yeah, unite pattern is what I want, right? I'm uniting like the different ones, right? A shape, B shape. Binding A and binding B. Biref A, biref B. This is just booleans. I think that it should work, and this should be two different bindings, right? Okay, how about we do this? Print unifying bindings at here and here. Span print and like I have 3 spans here. During processing this. How about that? So first we say span of the pattern A, and then we say span print B, and then we say span print span when processing something at the actual span. What do I click so that it like insert the pseudo? I think that's the feature of VS Code. Unifying bindings, unifying bindings, unifying bindings, unifying bindings. Oh wait, I say bindings. This is like patterns, right? Yeah, so like the last one was during processing of this over here, right? Yeah, that makes sense. When we're doing this processing, we're trying to unify this type and the type that is expected here from the monad itself, like this thing, right? That makes sense. Okay. So it seems like my patterns are... So I'm unifying the... this and that. And this is the same things. So the patterns are the same. But why are the patterns the same? But why are the patterns the same? That makes no sense. It's because unite pattern, span, arg A, arg B. These are different arguments, right? Okay. I think I'm going to remove this printing. But let's continue debugging by doing this, unifying generics at this and that. So I'm going to say arg A and arg B here. Unifying generics, this and that. That's the same one. Why would I be unifying the same ones? Like one of them should be different, right? Can I say, okay, can I say if span, if not, span equal arg A data span and arg B data span, then, only then I want to print it. Let's see if anything is getting printed in this case. I am unifying generics, this and that. Wait, it actually was happening. It actually was happening. These are the two things that should be unified, yes. Yes. Let result be this in result. Now this is a different type. So I need to do this. And over here I say united. Let's just say united here. I just want to know if I get to the end here. Is this happening during this unification or somehow later? Right. It is happening during this unification, right? Does OCaml guarantee the evaluation order? Hold on, I don't know if OCaml guarantees that. Does OCaml guarantee evaluation order when evaluating record expressions? It would be weird if it doesn't guarantee that, right? Because we have the side effects in the language. Short answer, no. OCaml does not guarantee the evaluation order of fields in a record expression. The compiler is free to evaluate or why would OCaml do that? That's wrong. If your field expressions have side effects, you are playing language roulette. OCaml just becomes worse and worse language every single, like, day when I'm using it. I'm learning a new thing, which is really bad. Is that true? Like, link. Give me link. I don't trust ChatGPT like that. Let's see if it gives me the link. Here's the authoritative link. Operations on data structures. The expression 1, expression 2 evaluates to the n tuple of the values of expressions. The evaluation order of the sub-expressions is not specified. Well, like, what the hell? Really? You have a language which has side effects, and you are not specifying the order of evaluation. Like, why? I can have so many bugs right now because of that. I mean, let's see if it fixes it though, right? Let's see if it fixes it. So I just need to like do it like this. Like, let argument be this. Let result be this. And only then we construct it. Let's see if that fixes. It actually fixed my bug. I can have a lot of problems. Like, this is not the only place where I'm doing this, because I was assuming that the language was sane. Can I find all of the places where I'm like doing these things? Maybe I can like have a preprocessor that does this automatically for me? That is doable, I think. That is doable. Is there maybe a PPX that fixes that shit? There is no one. Okay, why is that? OCaml's evaluation order of expressions is part of the language not specified by the standard. No preprocessor can change the runtime semantics of the language. It can only rewrite your source code into other source. Yes, but we can rewrite. Yes? There was at least one discussion in the OCaml discourse where someone mentioned an unreleased preprocessor that wrote record expressions into ordered let bindings to enforce evaluation order, but it's not packaged or standardized. Well, I mean, OCaml is not the only language. I know that something similar is also not guaranteed of the, like in C++. Yes, my life would be 1,000 times easier if I would use Rust here. But I think, like, what other languages have same problem? It is guaranteed in C++. I think, like, maybe in C, yes, C, right? C++ pre-C++ 17. Suppose C++ 17 fixed some sequencing. Because I remember something about C++. Show me C++ example. evaluation order of f and g as unspecified in C++14, right? So like they fixed it, but they fixed it like pretty late. Function arguments are only started to evaluate from left to right in C++17. All right. Yeah, but there is a lot of people who like, I don't know. I think there's a lot of people like C++17 is really fresh, basically, right? Okay, but I think I actually fixed my bug. Like, look, my stuff actually compiles and runs. My monads are type checked, and we actually type check properly right now, right? So what happens though? Let's say that this returns t like int32 then, right? How about that? Int32. Int32. And then I say 1, 2, 3 here. Then this doesn't type check. Okay. And like, yeah. I think I fixed it. Let's see like the actual monad example though. This still says something. Patterns cannot be united, underscore and t. Patterns cannot be united. Yeah, patterns cannot be united though is an understandable thing. I guess it's because over here. So I can, I can no longer unify this. So I'm trying to unify this type. But the actual monad, it actually gives the name, right? So this over here is a pattern that gives this thing a name, is the difference. The name is not used on the right side here because this always returns a type. But if I like say that over here unused, then now it type checks, right? So that's my current limitation, because when I'm unifying the types, I need to give variables the names in all of the places similarly. And this works now. Now we have cast examples, hkt monad. It doesn't work. Wait, what's the problem? Oh, t is not equal to trip int32 over here, trip singleton. That's while evaluating the generic though. Okay. Wait, why is evaluating the generic? Requires the type. I think I know why though. This is just not substituted or something. Because this is a trip of the trips. Yes. This is a separate bug. This is a separate bug where this is during evaluation though, it would be really nice if I did not need the types. The reason I need the types is because of blocked expressions, right? Let me commit anyway. Unifying patterns. I'm just going to say something like it's in the interpreter. It's in the interpreter core. We have a result type. Yeah, over here. See, when I'm evaluating instantiating of the generic, I'm substituting the type here. In the current span. This is not always correct, maybe, but we also have a result type. Let's look at this. Yeah, over here, for example, I'm saying expression data type. That is not correct. I'm going to substitute it here before doing that. Result type, body data type. That's going to be substituted here too. One, two, three, four. 1, 2, 3, 4. 1, 2, 3, 4. Okay. That's maybe fixing it. It's not. Maybe I need to like find the other place. Yeah, but basically we while evaluating instantiation of this generic, right? So yeah, the question is, what is the result of, so this over here is something like that, right? This is implicitly instantiating the generic. So I am just having the problem where I'm having the problem where at compile time we just know that the value here is of type T, right? But we actually give it the value not of type T but of type trip of ints, right? So that is the issue here. The issue is that the types, maybe inside of the instantiate result type, instantiation. Like, why am I even type checking here? That's the question, right? Why am I even type checking here? Do I have something like data type here? When I do this for the errors, that's kind of okay. Wait. Blocked value. That's over here. Evaluate expression claim. This has expression data type. This is another one that is wrong. Type is substitute the type of that. Okay. Construct bindings argument impl. I feel like this is not used at all anymore. I can remove this, by the way, altogether. Did I fix it yet? Potentially? Nope, not yet. Data type. Evaluate expression tuple. We have the type here. Where is this type used? Data type. That is potentially the problem. Evaluate expression variant. And that also has the type, which is not substituted. And the expression module. So module tuple variant are the things that are not substituted, right? What is this? Pattern matching. All right, you know what? I'm going to maybe find this bug off stream. I feel like have fixed already a lot. This one, I just need like to debug which exactly thing is not being substituted properly, and then find the place where it needs to be substituted. Yeah. So let's end the stream here. You didn't take a lot at the particle simulator? Oh, I forgot about it, I think. I clicked on it once and then we got raided and I got distracted, right? Yeah. Well, I need to go eat though and do stuff though. So, see you next time. Bye.